Hello and welcome to Emerald Hill Skies. This is a special broadcast from Emerald Hill Skies tonight. We're going to try to do a Messier Marathon. Perhaps you've heard of Messier Marathons before. Messier Marathon is an attempt to work our way through all 109 or 10, depending on how you analyze it, objects in Charles Messier's list that he made in the late 1700s of objects that he decided were close enough to confuse comet hunters. And this list is immortalized under the name the Messier list, and you see all of the objects that start with the letter M in his honor. And honestly, for most beginning amateur astronomers, it represents the first rung of the ladder, the beginning of your frontier in trying to capture deep space objects, that is galaxies, nebulae, clusters, both open and globular, maybe even a relic of a supernova, the leftover sort of remains of a supernova explosion. And we have several resources we're going to use. We're going to keep our eye on our screen because it is a picture of the west. I can see it out my window here where I'm observing, and we should be pretty close to our first object, which is going to be Messier 74. And we're going to use as a primary reference this book by Harvard Pennington. It's Messier Marathon Field Guide. And I think this is a really practical book. It seems to have a good introduction to the Messier list, and it also does a good job at giving us a kind of a sequence to go through. We'll be following Pennington's sequence as we work through the list. Before I go any farther, I want to make sure that our audio is coming through okay. So I'm going to... does a good job at giving us... Okay, sounds all right. Another book that we're going to use is a book by Stephen James O'Meara, and it's just called The Messier Objects. This is one of his series, Deep Sky Companions, and in this book he breaks down each object, provides a nice visual of it, a map that he's drawn with his own pencil sketch, and tells a little bit about it. Unfortunately, we're not going to have a lot of time to be able to watch and listen to his descriptions, but we are going to use some of his background. Another book we use is Don Mackholtz's book, simply called The Observing Guide to the Messier Marathon. Don Mackholtz is probably the foremost, experienced person on Messier Marathons. I think he passed away, last year. But before his death, I think Don had done something like 16 Messier Marathons at least. And those who are close to him have said that he was so good that he could go through the entire list by memory without any star charts, without any guides at all. He just took his manually operated telescope, pointed it, and used a viewfinder to find the object, and then looked through the eyepiece and would show it to you, and made it through all 110 objects, I think, twice. 2 of those 16 times, if I remember right. That's just memory. From memory, but his book is extremely thorough, and it shows how that depending on your latitude, you should conceivably have a time in the year when you are basically seeing all of the Messier objects in the beginning of the night and finishing them up in the morning. And what this basically means is that there is a gap of Messier objects that correspond this time of year to where the sun is. So during the daylight, the sun is not blotting out very many of the important objects. The last little resource we'll use is this magazine clipping from Astronomy magazine, and I guess this was probably a 2000, trying to remember if it was 2015 copy of Astronomy magazine, and I have engaged a few friends to help me laminate this and kind of put it in a nice little folder, so I'd have this nice color listing of all the objects in an easy spiral comb bound, whatever you call this, spiral bound handout. So I love that as well. But because of the pace we have to keep, we're not going to be able to say as much about these objects as we normally would. Normally we hang around on objects around 7 minutes for each object, and then it takes us another 3 or 4 to queue up the next one. So we're basically able to go on a, I don't know, an 11-minute cycle, 12-minute cycle, and in a typical 2 hours we can usually get through 10 objects. Tonight we've got to go at a much faster pace because we have the dare of 110 objects between sundown and sunup. And the ones here at sundown and sunup are very hard to capture because they are very close to the sunset. And I see we've got some folks that have logged on. Here's David from New Brunswick, the New Brunswick Canton Saint Cecile. Thank you for being a part of this, David. I hope you can stick around. Brian, welcome to you from Alabama. And Laura, good to see you from here in Kentucky. Kim from South Australia. It's great to have you here, Kim. I guess it's daytime there, and happy to have you here so you can help. You're very experienced and have done this kind of thing a lot, I know. So what we're looking at here is roughly the direction of the first target, which is M74, and we've got it set on a half-second exposure. Let's see if we can do 1 second. No, it's still pretty light out there, but I can see the sun went down 15 minutes or so ago. I forget the exact, let me get the exact sundown time here so that you can kind of see the effect of the sunset at 6:25, as a matter of fact, today. And boy, it was just so bright until just a few minutes ago. It is now 8:07 p.m. local, and we've still got a very bright western horizon there. We're set on 1 second and a gain of 0 so far. Ant, good to have you on, and from you're very kind. Lovely to see you continue your wonderful work in EAA and education, your enthusiastic advocacy, astronomy in general. Great work, Doug. You're very kind. I think Ant might stand for Anton or Antonio. I forget, Ant, if you'd help me remember also where you're observing from. And there's Nigel from UK. Boy, you're already staying up late, Nigel. I guess 5 hours, so it's probably already 1 a.m. there. 4 hours maybe, midnight. I forget this time of year after the time change. So maybe 1 a.m. So we're going to try to get started here as quickly as we can once the sun is set enough. Still not able to see a lot there, are we? Let's go ahead and move our gain to 100. Now, if you're not familiar with the channel, or if you're watching maybe the recorded version, I will tell you that we're operating outside about 200 feet away out of a Pier-Tech Tele-Station 2 observatory. And inside you can see there an adjustable height pier. And on top of that is an iOptron CEM70G mount. There's a little mount, what is that called? An extension there, a pier extension on top of the pier to get the scope up another, I forget, 12 inches or something, so that it could be essentially parallel with the edges of the rooftop. And then, as you can see, the top of the roof slides off. And we're using a RASA 11-inch telescope. Has a focal length of, I don't know, 620 or so millimeters, if I remember right, 11-inch aperture. And on the end of that telescope, we've got an Octopi-Astro camera interface fastened to that corrector plate, and then an ASI ZWO, a ZWO ASI2600MC Pro, a color one-shot cooled camera there, astro-specific camera, and it feeds along with this equipment, which is a couple of little utility things that's set on top of an equipment plate, a Losmandy equipment plate on top of that RASA. That's also a good view of the dew guard, the black dew shield on the front of the scope. And you can see in the right-hand side of this twin image, the Pegasus Astro power box that's mounted, the one you see on top there, providing power to several accessories, and underneath that a Pegasus-Astro USB distribution hub. And that's collecting the signal USB data from a couple or three accessories, including that little red camera you see there, the ASI178 monochrome camera, which gives us this view of the sky. And that is the big picture of the sky, and you can see we've got a ways to go before that picture will show us anything intelligible. That camera is not looking through a scope. It's just the pure 155 degree wide-angle view of the sky, and that kind of helps us keep our connection to the sky. All of this equipment feeds into this little thing we call affectionately a rig rack at the bottom of the pier, and that includes all the power supplies and distribution boxes for power, as well as the little box that's made by Icron. They call it Icron Raven. It's the 3124 version that converts all these USB signals into fiber optic cable, runs them about 200 feet in my office here, so I can sit tonight on a night when it's 33.8 degrees out there and sit in shirt sleeve environment here in my office. I've got the accompanying box that converts that fiber optic signal back into the data again and feeds into my ThinkPad, Lenovo ThinkPad laptop. It's running an i7 Intel V Pro chip, and running on software side of things, we use a software called SharpCap to do the imaging. And this SharpCap software that you see here is something you might use if you're an astrophotographer, but more so, it's almost custom made for this, electronically assisted astronomy. Why do I say that? Because it collects lots and lots of frames in the RAM of the computer and averages them out so that you don't even have to save all these frames. Imagine 12 hours of frames, how much space that would take up. With SharpCap, it's averaging all the frames you want it to average, and then letting you see that average frame in the real-time view. So it's a very valuable piece of software. We use a software called Nina in order to focus the scope. Unfortunately, we haven't been able to see any stars tonight yet to focus. Tell you what, let's do. Let's see if we go back to let's try to go back to our let's go back to the North Star. So we're going to slew. This is a camera that lets you see the scope, and that's a real-time, a live image of the scope. It's not just a picture like some of the pictures I was showing you a while ago. And we'll get back over away from that sunset, and we'll just quickly see if this lets us see a copy, maybe a few stars, so we can do a focus. We might be able to see a few here. And yeah, so let's increase our focus to maybe 3 seconds. And our gain is set on 100. And maybe we'll have enough to be able to do a focus. Still not quite enough. You can see barely. That's probably the North Star right there. So just really 3 or 4 stars present. The thing is, some of our targets set very quickly after the sun. So we don't want to waste a lot of time on, shenanigans like focusing. Tonight's all about muscle memory and speed and grabbing these targets. Jeff, good to have you here from Seagirt, New Jersey. My goodness, you got light snow there. And Antonio, I think it is. Anton or Antonio, saying it's 12:10 and now 12:14. So 4 hours between us and you over there in UK. Just kind of what I figured. What we'll do in order to focus in just a second is we'll actually leave SharpCap and go to a software that automates our focusing. But I think we're going to have a few more stars than this. Just still a little bit bright. This is a nice clear night. We were going to try to do this Messier Marathon this Saturday and Sunday, and we could just see the clouds coming in, and it was just not going to work very well. So we actually had to kind of cut bait and call it for tonight. So I'm fortunate enough that I can kind of shift my work around for my job, leading a nonprofit here in Louisville, Kentucky. In fact, I'm operating on the campus of that nonprofit, and I can switch my work around and maybe catch a 2 or 3 hour nap in the morning. So let's close the camera on Sharp Cap and bring up instead Nina now. And Nina is an astrophotography specific. Let's see if this is going to let us log on now. It's an astrophotography specific software. We're going to try to log on to the camera. I didn't see any kind of there we go. And then to the focuser. You know, before I try to log into this focuser, I wonder if Sharp Cap still grabbed hold of that. Let me try and see what it does. Yep, it let us have it in Nina. The way Sharp Cap works, it kind of hangs on to the camera, but I guess it didn't hang on to the focuser like that. It won't share the camera with anything else once you've grabbed the camera in Sharp Cap. Now this is our goal, to get to this kind of hyperbola, or not hyperbola, parabola. To get to this parabola, that's our goal, but you got to have several stars. I don't know exactly how many that will require. Let's say 10 or 20 good stars, and we'll see if we have enough here. So what it's doing now is it's taking the first 10-second exposure, and then it will take another 10-second exposure, and it'll compare the two, and it'll try to decide which one. Yeah, it's not dark enough yet. This is not going to give us enough of a star base yet to be able to have good focus, sadly. Pretty sure this is going to fail on us. Got to have a good 10 or 15 or 20 stars there to be able to do this. Let's see, Michael, where are we going today, Mr. Emerald? We're going to try to go to all 100 and at least 109 objects in the Messier list. Yeah, it's saying not enough stars, so we're going to cancel out of the rest of this. I don't know, you probably can't see off to the side, way down to the right, that it's basically, let's see if I can move one of these up. I don't know if it's going to let me move that up. No, it's not. But it says not enough HFR difference for set of focus points. It says either the step size is too low or the stars are too much out of focus. And in this case, it's just that there aren't enough of them. If we go to the imaging screen here, we might be able to take an image and sort of look at what Nina is seeing. Michael says, sounds like a plan. That would be fun, wouldn't it? We'll see if, there we go. Now we're snapping a 5-second exposure here. And it's still, that's the view it had. It's still a very daylight view, sadly. But hopefully we'll be able to grab that focus soon and then head to our first target soon. Don't have much time to waste. Let's try again. The Messier Marathon is done out of order from the actual objects. The objects are numbered 1 through 110, but that's the order that Messier basically published them in. And they're not in any kind of order by where they occur in the sky at all. It's very random. So you kind of have to rearrange the objects. And the first object in order that we need to go to is the one that's going to set first. And it's it's M74. So I'm going to go here to localize. I'm going to set it on now and run this, and I'll pull this over so you can kind of see what I'm looking at here. The object we're trying to view is at 27 degrees still so far. So we want to catch it before it gets down. You know, we don't want to let that get down to 15 degrees. So we're gonna have to get here soon. Still not enough stars for autofocusing. So I'll tell you what we're going to do just to make sure that we don't waste our time on focusing. Let's go back to Sharp Caps. We're going to unplug here and unplug the camera, and then you go back to Sharp Cap. Let's log back onto the camera, and now see we might be out of focus, but we're going to scoot this down to about 1 second. Still a very bright horizon there. Oh, there's some stars. Let's set this on 100 gain. Now we're talking. So now let's slew back to M74 and see what it looks like. So we're going to go, we have to restart our tracking because we went to the 0 mark. It stopped our telescopes. We're going to log back on and then slew back to M74. So you can see the sky is just starting to darken. Tonight's going to be moonless till about, I don't know, 3 a.m. or something like that. Ideal would have been this Saturday. Yeah, 3:30 a.m. The moon comes up and it's about 57%. Not at all helpful for a Messier Marathon. Okay. So we probably don't have enough stars, but look, the focus is not terrible, is it? Let's, we probably don't have enough stars to do a plate solve. And we're going to need that because we got to set our scope for the first object of the night. Without good plate solving, we won't have good accuracy. Let me see what you guys are saying here. Understood just by the time you found them. Scott from Niagara, good to have you aboard. Oh, so sorry about clouds at Niagara Falls. Nor'easter there, Michael heard. So we do have quite a bit of clouds all over. So that's 1 second. Let's go ahead and go to our maybe 5 seconds or so, maybe see what we see. Still not a lot. Just beginning to see now stars in the neighborhood of M74. And as soon as we get enough in the frame that we can plate solve, that's only 4 stars, so I don't think that's going to be enough. Let's increase our maybe let's run up our gain to 200 and shorten our exposure back to 4 seconds, maybe even 3 seconds, and set our gain a little higher. Let's see if we can cheat here. Try to get a few more stars in there and faster exposures. somewhere in between there, 250 gain maybe. Okay, let's go ahead and try plate solving here and just see our luck. See if we have enough. So plate solving, if you've watched the channel before, you know that it's taking a picture of the nighttime sky and comparing it to its plates or memory images in its memory. And then it tries to find, okay, I see where you're actually pointing, but you had said you wanted to point at this certain spot. And sure enough, it was successful, and we were off by about 0.8 degrees. So this will enable us now to be, Lord willing, really square on to M74, which is a galaxy in Pisces. It's currently supposed to be around 26 degrees above the horizon, so still high enough theoretically we should be able to observe it. And the mountain is synced, and here we are. So, boy, there's not a lot in that frame that we can see. Why don't we set, why don't we keep gain on 200 and go to like 3-second exposure and see just what that looks like. What we're trying to see is a galaxy, so it is very faint. And I don't know if we plate solve something, if we live stack something that bright, if we're going to be able to make anything out, but we could try. Let's try going with 1-second frames and bump up the gain. So these are 1-second exposures now. I'm going to let you guys see the screen. Yeah, it's a shame that Corey's not doing much on line now. That's true. P. Lark, good to have you on from California. Now, just to get an idea of where that target should be, it should be right there in the middle of that frame. So kind of watch that, and let's try to live stack some and just see what happens. This is going to be M74 when it finally comes. I like the stress of Messier Marathons because it forces us to use all of the muscle memory that we've been able to accumulate, and it kind of forces us outside of our normal patterns, and hopefully when it's all said and done makes us into a better astronomer in our normal patterns. So what I'm doing here is kind of tinkering with these sliders. They're slider bars that let you adjust the parameters of the live stacking process. And the averaging of these frames going to go to a longer exposure now. Let's go to 3 seconds. Or I'll tell you what we could do is go to 400 gain and keep it at maybe 2 seconds, because it is getting a little dark over there now. And we want to try to catch this object as soon as we can so we don't lose it. Right, adjusting the wavelength, right. That's pretty much it. What you're doing with this left slider is you're defining a new black level point. I don't think this light is the light we want, is it? I don't think it is. I think that's like the horizon light. But that is interesting that we have two distinct bands of color, isn't it? Yeah. One must be the, the leftover horizon light, and then this is the pattern we're used to seeing for the stars. So I'm just kind of ignoring this little set of color peaks over here because I think that has to do with the horizon. And you notice what we can do is do a color balance here, and then we define the new black level here, and we say don't let any of that other bright light in. The problem is when we do that, we're also blocking out the light of the galaxy. So with each of these objects, we have a star chart that we can use to kind of see the stars around each object. So for instance, here's the star chart for M74, and you can see that M74 is a bit of a very poorly defined galaxy. It looks like a big glob there, doesn't it? But look at all those dots around it that we can't see yet. And then what we try to do is we try to use this star chart sometimes to kind of get a picture of where the object should be, and not really making out enough to be able to, there are those three stars, so we kind of see where it ought to be. Let's maybe now try 3 seconds. Just for comparison, we're usually doing 20-second exposures when it's dark. So this is completely haywire astronomy here when it's not really dark yet. Actual astronomical darkness doesn't really start until around 9:30, and it's 8:30 right now. So this particular time of the night, you know, this would be considered dusk, I guess. Maybe it'll finally be dark enough by 9:16. But what we try to do is we try to catch this because this object will not be long for this world. Let me see where it is now. It's going to be it's at 24 degrees above the horizon now, so we want to try to catch this soon. I'm going to try to restretch our display histogram up there, and then here, let's pump up these mids a little more. I can't tell yet with all that lightness there at the side of the frame. I can't tell. Now maybe we're starting to see an object maybe form up right here. I think it should be more up here, but look, we're starting to see some patterns there. Yeah, that might be the core right there. Let's look in O'Meara's book at M74, and that'll give us a better picture of what we're looking at. Oh yeah, there should be a bright core and a spiral. See that nice shot that O'Meara has, and basically he says it's very difficult because it's so faint. 32 million light years away. This object was actually discovered by Messier's assistant, Pierre Messier, in 1780. But they were using, I think, I can't remember the width of that scope. Was it a 4-inch? I can't remember. Anyway, O'Meara says how difficult it is to spot, even in a 9-inch that he was using. Let's do another color balance here now that the sun is set. And let's dial up these mids a little more. Maybe we'll try to darken the background and dial up these mids here. Still kind of difficult, isn't it? Maybe let's try going to 4-second exposures now. This is definitely a different kind of astronomy. Doing astronomy through a Messier Marathon is a bit like, you know, more of a snatch and grab. Whereas normally we're pondering about an object, we're appreciating its beauty, we're observing it for 7 or 8 minutes in a completely dark sky, hopefully. Man, now in this kind of sky, we have a completely different goal, and that is just to witness the object. We're just trying to witness it. And tell you what we can do, just to make sure that we're viewing the right part of the sky. SharpCap has a neat feature that you've probably come across before. It's deep sky image annotation, and it shows you where it thinks the galaxy is. What we're going to do first here is we're going to ask it to, let's take this deep sky image annotation off, and we'll plate solve again only. This time we're not moving the mount, we're just looking for stars that the software can recognize, and then allowing it to resynchronize its own recognition on this part of the sky. And then that'll give us a more accurate deep sky image annotation. So as soon as it has solved this puzzle of what stars are these, that's basically what it's asking. What stars are these? We'll deep sky image annotation again, and right there is where this galaxy should be, M74. The trouble is it's 9.5 magnitude. For comparison, 5 magnitude, something like 5th magnitude stars are the most you can see in a kind of a typical dark sky. If it's an amazing dark sky, you can sometimes make out 6. But in a typical dark sky, you can only see to 5 or so. So we're trying to see something that's way past the limit of typical sky. And I hope this is not the tree line. Let's go over here to our planetarium software, and we'll show this part of the sky. And what we've done to this part of the sky is we've created a line that simulates the tree line here at Emerald Hills. And then we've stuck a picture of the tree line a little bit below that. And that way you can kind of see, well, what has just sunk beyond the horizon. You know, Jupiter has. And Venus is right here. So you see, we still have from this point to this point, supposedly, to be able to catch this object. So we're doing okay so far. It's at 23 degrees, and this tree line is probably about 15. Now you say, why did I say supposedly? Well, it's because this panoramic night sky simulation is just that, a simulation, and it is not an exact science. So we can't take this tree line simulation to the bank. It's an approximation at best. But it does give you an idea of the real tree line. You say, well, now the trees are down here. What is that line? I did this on purpose. I've got the line representing what I think is a tree line, and then the trees give you sort of the feeling of it. And this little space helps you see any kind of difference that you're off a little bit. Okay, so that's what we should be seeing. And when we zoom in, you can see it's called the Phantom Galaxy, which is a great name, isn't it? Phantom Galaxy, because of the fact that it's so difficult to capture. No wonder they call it the Phantom Galaxy. All right, so let's redefine things here And let's bring our mids up a little more. Let's keep our whites kind of out of the way. And let's get the deep sky image annotation out of our screen so that's not in our way. I'm going to see if you guys are seeing anything. Looks like P. Lark said, can't see anything in California, just water. Michael's saying, yes, I can see stars. And Michael says, how does a galaxy rotate? Well, it rotates very quickly in its own galaxy, but from our perspective, it's not very fast. It's because of our distance. Curtis, good to have you aboard. Lots of rain out there. I'm so sorry to hear that. I remember, Curtis, you've done some of these marathons with us before. You've helped gather these images. Where's Betelgeuse in that chart? Nowhere near this. Anne says, bless you, Doug, for all your great work. Alas, it's late here, but I look forward to watching your compiled upload tomorrow. Good night, all. Anne, we understand that from UK. Thanks for checking in as we began here. Tell you what, I think I'm going to go ahead and put on our darks here. I'm tempted to start the stacking over again because it is looking fairly dark out there now, at least to my eyes. Let's stop this live stack because we don't have anything appreciably there yet anyway. Let's go with back to our 100 familiar gain and our 20 seconds of time. Kind of get of the sky. We've still got quite a bit of glow there from the sunset, don't we? And that's the glow we're seeing. And there you can make out that tree line. Okay, so here is, now let's start live stacking here. I'm a little more familiar with this, and we'll clear the last live stack. A little more familiar with these settings. We'll see how this does. You might say, well, if you knew that it would be this hard, why would you start so early? Well, it's because M74 is difficult to catch. And what we're trying to do is give ourselves a maximum possibility of catching it. Okay, so let's do a reset on our display histogram. Now let's do a reset down here on an auto stretch, and then a color balance, and then, aha, now we're going to see it. Okay, so we're going to zoom in here. So it's still very grainy, but now you can see M74. What we're going to do is keep it a little bit there to the right of that crest. We've got the mids turned up pretty high, but you can already see the core of the galaxy forming up. This is not the ideal time you would want to observe this galaxy because, like I say, not only is it lower on the horizon, now at 22 degrees, so it's looking through 9 equivalent air masses compared to if you looked at it when it was straight up overhead in 1 air mass. You're looking at it through the equivalent of 9 thicknesses of atmospheres. But look, there it's forming up. And there is a lot of green there yet. But that is just 80 seconds. And we are going to successfully capture M74. So what this does, it gives us, it's 8:44 and wasn't even supposed to be dark until 9:15. So this allowed us to be almost a half an hour ahead of schedule. Now you might wonder, does this count? To see M74 in this way, does it count? Well, on a Messier Marathon night, yes, it counts. It's ugly, it's grainy, but on a Messier Marathon night, when you've got about 3 minutes per object, you have to take it. You got to track it, right? Just takes time, right? And we don't use a lot of time on Messier Marathon because this is the first of what we hope why are you saying 109? The reason is because we do not anticipate getting the last object, M30. It's going to be impossible, virtually. Not only is it kind of behind the building where we observe, but it's also buried deep in the sunrise. Okay, so that's our version of M74 on Messier Marathon, and I know it's ugly. But you can see the core. You can see a few of the spiral arms starting to make their way out there. We're just pumping up the grain. So here's one spiral arm, and there's another spiral arm, and that's the core of the galaxy. And you're looking at a galaxy that is a visual magnitude of 9.4. It's only 9 arc minutes wide. It's 40 million light years away, about 100,000 light years across. Okay, we're just going to save a copy of this. And tonight we're going to try, let's do one more plate solve at our next target, just because we need to. I'm going to go over here under observing, and I'm going to say ugly. Whoops, we got to set the date, don't we? It's a new session, and it is starting now and going until 3:15, March 15th, 2023. And we're going to try to go, let's say, 8 a.m. Just to cover our bases. And if I remember right, I think this is session 109. We'll check that later. Messier Marathon. And then we're going to say ugly, but saw the core and 2 of the arms and had to move on. So there's the observation of M74. The next target is M77. It's in the galaxy Cetus. And we're going to slew to that. M77. You might say, well, how do you decide? How do you decide the order of things? Well, it's a combination of factors. Which object is about to set, and also how close is an object that we can get to. Another factor is time, just trying to save time, and I think this might be it right here. That might be the galaxy right here, but look at that great star pattern we're getting now. This is working really well, and the focus doesn't really look bad. I mean, we didn't get to do a focus yet. That's just remembering our focus from last time. Now that little scrape that you're seeing there, the little stars scraping across the sky, that is the mount correcting what it's pointing at, and sure enough, that's the object that we were seeking. M74 was one of the first objects observed by the JWST. Thanks, Stu. Good to have you aboard, Stu. Wow, I didn't know if you'd be on, because it's actually morning hours down there in New Zealand, in Tauranga, where you are working from. Curtis says, is there a group this year? Curtis, I gotta say, this is very sad, because as you recall, the folks at the forum that we were working on, they decided they didn't like the way I would promote things. And since they are, in effect, an astronomy store and they're promoting their own things, they actually just ejected me off the forum. So I have not been able to be on the forum for some time, Curtis. And yes, Frank, I'm trying to do this solo this year. Stu is telling us about M77, And Frank, I want you to know I miss you guys because you guys are so much more experienced, and it gives me such a better, you know, security knowing that you guys are there. And we would like take turns. Remember, Frank? We would take turns grabbing objects, and that way it was easier on everybody. Now, again, just to be sure, there's M77 right in the middle, so you know that we're on the right target. And you can already see it forming. This is after just 80 seconds. Still not absolute, you know, civic darkness. Right, our group does not have any ties to Cloudy Nights, but, okay, Curtis, thanks. We did rename ourselves, but they still kicked me off anyway. Sad to say. And I really wasn't promoting some kind of product for sale. I was like promoting these events and stuff. And that, I tell you what, it irked them that I wanted to try to help us assemble a book on electronically assisted astronomy. And the book was even just going to be a website, as you know. It's going to be a live book that was alive, but then they didn't like it because they said I was promoting another website other than theirs. So at the end of the day, they just said, we kick you off. Now look at the Stephen James O'Meara image of this. This is M77. It's a peculiar looking spiral galaxy. And now let's go back to the screen. And that's what we have. We have a very small version. So we'll zoom in on it. And we're going to save this and move on. And this is the pace that we have to work. And then our observation, we're going to say this was starting to look just like the O'Meara picture. Haha, at 3 minutes. And now we're going to say next object. Now from here on, let's try it without plate solving for a while and see how we do. So the next object is M31. And that one should be a little easier, shouldn't it, guys? Laura had to say goodnight. Great joy with the marathon, Doug and friends. Rest well when you get there. Good night, all. It's getting glow time. Great picture, Michael says. Well, bless you, Michael, for cheering us on. M77 was discovered by Pierre Michon in 1780, originally described as a nebula. Frank says, clear outside, shows pretty nice skies on Saturday night, Sunday morning. I understand it's short notice, but I'll be available if we want to give it a go. That's the thing. The weekend is really cloudy for us here, so we are not going to be able to do it from here, unfortunately. Sad to say. Okay, so that's how fast we can now set up since we're not plate solving. But look, it's waiting for that. Oh, it's waiting for the first exposure, I see. Both Messier and William Herschel described this galaxy as a star cluster. Wow, you can already see a beautiful object there. Now, we're not quite centered. That's the problem with not plate solving, huh? In fact, I fear, well, we might, if that's, maybe that's 110 right there and 32 is inside. We'll see here in a second. Let's at least go ahead and work on 31 here. Isn't that a beautiful sight already? That's after 40 seconds. Let's do another color balance just to make sure we get this. Now look how you can already see these dust lanes after just the 40 seconds. I fear, let's use the deep sky image annotation. Mount has moved too far, so we'll have to plate solve only. But at least here's 31. So now we're going to say add observation. And we're going to say saw dust lanes after just 40 seconds. Yeah, that's M32 right here, unfortunately. So that means 110 is off of our frame. So that's sad. But we are going to be able to observe 32, and that's about all that you can see on 32. Let's get rid of deep sky image annotation. And so you see here, this is almost just like an elliptical. It looks almost like an elliptical galaxy. We're going to say M32 showed up as a fuzzy glob after just 40 seconds. So we're going to go ahead and save this, and then we're going to slew, but it won't be much of a slew, to 110. I'm going to stop the live stack. Next target without plate solving. Slew to 110. And it should hopefully move in the right direction, yeah. And Michael says, thinking this is going to be a rainy season on the west. Mark McGee, good to have you from Nebraska, Mark. Michael's from Ohio. We aren't seeing, oh, I'm so sorry. There we go. Thanks, Frank. Okay, so now we can see 110 forming up here. And we're going to reset our display histogram over here and then restretch the live stack and then reset the color balance and then maybe adjust these a little down. And then this is 110 right here. So whereas 32 is above Andromeda, 110 is below Andromeda, a little bit farther away. And again, there's not a lot of detail that you can see there in 110. Typically, it's kind of, it lives in the shadow of its greater companion. But we'll zoom in on it at least. And as that confetti starts to disappear, we'll maybe see just a little bit more of that fuzz. Yep, the gas swirl, right, Michael? The Andromeda Galaxy is really amazing. And now you can start to see that we're not in perfect focus. So this is a good time probably to duck out. Let's grab a quick picture here, just the fact that we did. And let's do a quick observation. 110 was visible as a blob almost immediately in a 20-second capture. So what we do now, we stop the live stack, we drop out of the camera. Actually, I probably don't want that galaxy, do I, in this frame. So let's go over here to just pick out, let's show the chart where we are, and let's pick a star out that's not got a galaxy in it. Something like this. And let's slew to that. That's good. And so what we're using now is we're using Stellarium to steer away from that object. And we're going to go back to Nina, and we're going to grab the camera in Nina, grab the focuser, if it'll let us, yeah. And then we're going to do a quick autofocus here in Nina, now that we've got darkness. And now we can catch up on Stu telling us that M110 was independently discovered by Caroline Herschel on August 27, 1783. Her brother William Herschel described her discovery in 1785. So I guess what you're saying then is that Messier never included 110 in his last supplement to the original catalog. He stopped at number 103, but he did observe the object in 1773. He observed this object in 1773 as evidenced by a label in his own hand on a drawing a full 10 years before Caroline Herschel, who is generally credited with the discovery. The object was, quote, added to the Messier list sometime after 1967 when it was proposed by K. Glenn Jones. Owen Gingrich has much to say about the additions to the Messier catalog in Malice and Crimer's Messier album. It is entertaining and enlightening reading. So what Harvard Pennington points out is, although Messier didn't include it in his catalog, we know by his journal that he observed it because he put a label beside it in his own handwriting, identifying the fuzzy spot. So what they did is they added it as the 110th object in the Messier list, after Messier had only published 103. So these extra objects above 103 will all have been added by people who've studied his notes. And they said, look, the guy did discover something, he just didn't put it in his catalog. And I don't know what motivated Messier to, publish this list other than, which has been well announced, it was to avoid these objects. So I guess the bottom line is he never thought that M110 was going to get in his way, or else he just forgot to include it in a published list. So you might be wondering what's going on here. This is this autofocus routine in Nina. And what it does is it keeps moving the focuser in one direction until it notices in a computerized way the bottoming out of the stars getting more and more to be pinpoint-like. And you can see that when we started, the stars were this wide, so they were out of focus. And as we focused, they became more and more pinpoint-like. And then Nina will move the focuser past that pinpoint light until the stars are measurably bigger. And when it begins to notice that these stars are becoming bigger again, it'll say, okay, now we know for sure we've gone too far, and it will automatically bring the focuser back to this point here, somewhere along this part of the parabola. And this entire magic works a lot better with a telescope like a Rowe-Ackermann Schmidt Astrograph, because the Rowe-Ackermann Schmidt Astrograph has such a narrow field of acceptable focus range. The acceptable focus range is something like, I don't know, 30, now see there it's focused, it decided it liked this spot. And so now we're going to go back to the equipment and we're going to drop off the focuser and we're going to drop off the camera so they don't get in the way. And now we're going to thank the programmers of Nina, and we're done with Nina for the night. We're going to go back to SharpCap and pick up our camera again and head toward our next object. So now we should be a lot more, yeah, we're all the way zoomed in here, and you can see our stars are much more pinpoint now. They were just almost like donuts a while ago. The temperature has dropped some. Let me see what the temperature is now. 29.7. And when we started it was 35-ish, 34-ish. So every couple of degrees we're going to have to adjust our focus through the night if we want to keep it really accurate. All right, so we finished with 110. We did M32. we're ready for M33. And Stu, you were asking about, do we have the scope cam back? And yes, I'm happy to tell you that we do. Hallelujah. So there you see this. Well, now wait. Are you seeing the scope cam? Well, we had it a while ago. What in the world? Let me see. I'm not going to spend much time on this, but let me see if I can find it again. I'm going to pick another camera for a second. Let's pick this and then go back to that and see if we can wake it up. Well, that's a shame. It's gone to sleep on us. You know, I didn't replace it, Stu, because when we got into it, we discovered that it was actually not the camera's fault, that when we had installed the Wi-Fi, the camera cable had been pried loose from its extension, sadly. So that's why it was appearing to have malfunctioned. But the truth was it actually hadn't malfunctioned. It had just, the cable had come apart. But now tonight, you're right, Stu, you were pretty tricky to notice. We have Skycam and DougCam. Yeah, you were astute to notice that it's dropped back out again tonight. So we did order a replacement. Boy, right there it is. This is going to be a quick target. We did order a replacement, and we set up the replacement to use when we were observing live out in the observatory. But now that this has gone bad again, we will actually pull that new camera, the new replacement in. Look at this, after 40 seconds. Isn't that remarkable that you can get that image after 40 seconds? And it's 9:07, it's not actually astronomical darkness yet. Doesn't reach astronomical darkness till 9:15. So this is M33. And we're going to say we could already see the pinwheel nature of M33 after just 40 seconds. Astronomical darkness hasn't descended yet and won't for another 7 minutes. Tell you what, you just cannot discount the focal ratio of 2.2 of a RASA 11-inch scope. I'm not one to, because I didn't make the scope. I mean, it's not my invention, but David Rowe and Mr. Ackermann came up with an incredible design that it will drink in light this quickly, even though we don't have darkness yet. That's 120 seconds, and we're gonna call it that. Let me rename this. Oh no, we already did rename it. So that's M33, and we're gonna stop live stacking and head to M34. I'm amazed because that took us all of 1 minute. Next target without plate solving. M34, slew to it without Stu's scope cam. M33, or the Triangulum Galaxy, is the third largest member of the local group of galaxies behind the Andromeda Galaxy and the Milky Way. So now we're looking at M34. Boy, Stu, your commentary is really helping tonight because we do not have time on this end to be able to read it. Now this is an open cluster, M34. You can see it forming up here. We don't actually need to do live stacking. We're just going to take one picture of this. 1 20-second snapshot of this. You better be quick, Stu. M34. I'm just going to I'm going to reset the display histogram and reset the live stack. And this is the open cluster we're looking at, M34. And Stu's going to tell us about it. M34. Thank you, Stu. Okay. Next object let's plate solve once. On M76, which is a planetary nebula, on M76, I'm sorry, on M34, did we do an observation on that? 4222, we didn't. So we're going to say, nice open swarm. And this next object is M76. Stu says, I'm on a smoke break. Sorry. Stu, you don't fool us a bit. You are making a sandwich. I know. Well, no, it's breakfast time there. You're cooking fried eggs. Stu, you rascal. Okay, M34. What does Harvard Pennington say about it? He says, a bright open cluster easily seen in small telescopes binoculars, discovered by Messier in 1764. It's a naked eye object under very good condition. It's a low power object, about 80 stars, easy object, 1,430 to 1,500 light years away, true diameter 4 light years. Main body of easily visible members. M76 is the little dumbbell. And it's a planetary nebula. And you guys know that planetary nebulae are the outer ejections of material from a star that began to shrink because it was collapsing and dying. And as it collapsed, it sort of jettisoned some of its outer layers, but then, as if it couldn't make up its mind, it collapsed enough to re-energize itself. And when it did, it lit back up. And when it lit back up, it then backlights the material that it just jettisoned out. So imagine an inflating balloon, except it's not really like a latex skin. It's more like layers of gases and such. And sometimes we get lucky and the layers of gas jettison in the direction of the gravitational poles of the object. And look here, that's what's happened. The star is in the middle and the material jettisoned out. And if you look really closely, I'm going to go beyond our optical zoom and we're going to get some mosaic. But can you see the colors out here? That's some extra like hydrogen that was out here. And then this is lots of maybe oxygen, nitrogen or oxygen here, probably oxygen mostly. And it's being backlit by that central star. And although we can't see the central star very much yet, we can make out some nice color in those red ends of this object. Breathe, Michael says. M76, also known as Little Dumbbell Nebula, a planetary nebula located in the constellation Perseus. The nebula lies at an approximate distance of 2,500 light years from Earth. Mark, you can team up with Stu and you guys make a good team. Thanks, Curtis. We'll look forward to it. That star took a major bong hit. Yeah, I'd say. Now, if you look really closely, you can see the little white dwarf-like center now. Can you make out that little white dwarf-like center? This is 2 minutes and 20 seconds, so we're going to move on to the next target. But this is a beautiful thing, and look how you can see these little outer, what would you call those? Little outer extra layers that were jettisoned off in another life. So they become like ears on the little dumbbell, you might say. And over here in our observation, we're going to say we could see color red hydrogen tips and also the extra wide ears layers at 2 minutes. Man, RASA's rock. That's what I think. RASA's rock. Okay, we're going to go to the next object and we're going to skip plate solving. And this is a globular cluster. So the next object is going to be M79. And we're going to salute to it. I'm so sorry. I had this scope cam working. Let me try this again. See if we can. There is another camera. Just will not activate. Sorry about that. Anyway, here we are. Maybe during the break. We'll do a break in the middle of the night. And it'll be like a, I don't know, depending on how fast we go, it'll be like a 2-hour nap. And during that break, we will try to get that other camera working. This is somewhat of a mess. Are those satellites or airplanes that photobombed us? Or it looks like we had not, maybe we didn't clear the last live stack. What in the world is that? Let's stop this live stack. And this should be a globular cluster anyway. I wonder if we had not stopped the live stack. So let's just go with 4 seconds and try a gain of 300. Stop live stacking. There we go. 4 seconds, gain of 300. Boy, let's kick it up to 400. I was thinking this globular cluster would be visible. Maybe it's because we are not right spot on it. Is that it, maybe? Let's go ahead and plate solve. In our movement, maybe this is it. Plate solving is a spoiler, isn't it? Because you always kind of know you're going to be right on. Kevin, you're amazing. I love this, how you've created this channel, explain these concepts. I would love to know how you reconcile the science and the data of astronomy with biblical timelines. Mark says, could it also be swirling? I don't think those, honestly, I don't think they swirl, those planetary nebulae. I don't think so. Oh, I'm glad. Kevin received your t-shirt and sweatshirt. Send you a pic. That would be great. Michael, breathing stars wild. I never thought about that. Mark, Messier 79 is a globular cluster. There it is, right in the middle now. Yeah, so we really don't need any more than this. That's already beautiful, isn't it? It's in the northern constellation Lepus, the Hare. The cluster lies at a distance of 41,000 light years from Earth and has an apparent magnitude of 8.56. We're going to do a snapshot of this. And this is a very old cluster. I mean, I don't know whether it'll tell us the age, but I mean, probably if we look this up, let's see if O'Meara tells us what astronomers tell us is the age. But I mean, it would be like 8 billion light years away or something. In other words, it would be one of the oldest things in the universe, these globular clusters. Anyway, so how do I reconcile this? Well, I kind of think that what we've got here is an apparent age, and the way I reconcile it is, first of all, to realize, well, the Bible's not a clock, so there's no reason to think that the Bible ever claims to be a clock. And then the second thing is, these are all apparent ages. So if God did create all this 4,000 years ago, then he created a universe that was in process. Kind of like when the president interrupts your program to give an announcement, and then the announcement says, we join, Blue Bloods in progress. And what they mean is, Blue Bloods already started 8 minutes ago. You just didn't see the beginning of it. So now you don't exactly know how it started. Well, that's the way we look at the universe. If God really did create all this 4,000 years ago, then he created the universe in progress. That's the way he made it. And these things were already moving. The light was already in movement. It was already on its way. And bam, everything was created in motion. If he's God, he could do that. And so we don't know how Blue Blood started. We don't know how the universe started. That's the explanation I use. See what you think about that, Kevin. Okay, that's my wife saying, I tried to get on, but no luck. Listen for about a half an hour. If you can hear, Penny, good night. I hope you have a great sleep, and thanks for checking in. It's awesome. This is M42. You can probably tell that because it's one of the most spectacular regions. Just look at that. It's one of the most spectacular regions in the night sky. And I hesitate to live stack it just because you can already see so much of it, right? And look at how this, these 4 stars in the middle are already blowing out because it's already too bright. So it's almost like we have to go down to like 3 seconds in order to see those 4 stars correctly. Now that's 3 seconds. Let's go down to 2 seconds. Let's go down to 1 second. Remind me the name that we use for these 4 stars. It's something like, see, that's a half a second. So that's too dim apparently. So there's 1 second frames. What's that called? It's like, doesn't it start with a T? Trapezium. Thank you, Frank. See how that trapezium is blowing out? We're going to reduce the gain to like 200 and see if we can, there you go. So there's the trapezium, those 4 stars. And they're lighting up all the gas around it. So we'll drop back up now to 400 and go back to 3 seconds so we can see all that gas that's around it. And look at all the hydrogen being lit up like a neon light. Look at the definition of this hydrogen front here. This entire area is just a giant area in the constellation Orion. M42, and we'll say to see the trapezium, we had to drop gain to 100 and exposure to 1 second. Then we could see the 4 stars in that cluster. What an amazing patch of the night sky. Of course, this is so bright that you can see it with your naked eye. And in binoculars, it's just a spectacular object. We're not live stacking. This is a live image, 3 seconds. Yeah, Stu confirmed that that globular cluster was 11 billion years old, we estimate. M42, 24 light years across, so its apparent size from Earth is about 1 degree. Kevin, Bible's not a clock, so true, but I also don't think that God created an apparent age. I would rather believe that the Bible, not a scientific journal, shouldn't be held to the standard. There you go. That's the easy way to explain it. Frank, thanks for the encouragement. Orion Nebula is one of the most scrutinized and photographed objects in the night sky and among the most intensely studied celestial features. That area would power us forever. Astronomers have directly observed protoplanetary disks and brown dwarfs within the nebula, intense and turbulent motions of gas, photoionizing effects of massive nearby stars in the nebula, and besides that, it's just beautiful. Okay, so that's M42, and then M43. Let's turn on our deep sky image annotation. Whoops, we're going to have to plate solve only here real quick so we can resynchronize, because I think isn't M43 so close that, like, I think isn't this M43, for example, if I remember right, I think this patch out here is M43, so it's in the same frame. Waiting for it to grab all these stars, look at it with its memory, and then hopefully say, oh yes, I know where you are. So that's M42 is right here, and M43 is right here. Yes, exactly what we thought. Marin's Nebula, M43 is right here. So let's back out a little bit and just look at all the stuff here. Over here is the Running Man Nebula. These are all NGC objects. I don't think there are any more Messier objects here that made it into Messier's cluster, Messier's catalog. So we'll go to M43 and we'll say in this observation that it's a nice asymmetric balance to M42, instantly visible in 3-second frames. Okay, we'll turn off the deep sky image annotation, and we don't have live stacking on. That was M43, so now we'll head to M78. This is our 12th object. Somebody help us calculate our time. What's our pace here? 9:30. We got started around 8:40, didn't we? So 12 objects in 40 minutes. We're not bad. We want to stick to 3 minutes if we can. Let's go ahead and try to view this. It's a diffuse nebula, M78, but let's just trust that we're close enough. We're going to have to live stack this, aren't we? Let's try it without live stacking, just out of curiosity. Let's take one 20-second frame at a gain of 100 and just see if by chance this shows up in a 20-second frame. And if it doesn't, we'll go to live stacking. Turbulent motions of gas, they do swirl. It did not, so this is a faint thing. We're going to go to live stack and clear the last stack. We're going to change our name here to M78. Again, these numbers are not in any kind of order in the Messier list. Basically the order he discovered them most of the time. Now we've got this nebula. And I like this nebula. It's got a kind of a ghostly look to it. I wonder if this is still close enough to be able to do deep sky image annotation. Yes. So here's M78, and there's also NGC 2071 over here. So M78 is here in the middle, lit up by these three stars. And what we have here, when it's mostly green, it's probably a sign that that's got a lot of oxygen swirling around it, not so much hydrogen. But it also depends on how you color balance it too. So over on M78, we're going to say instantly visible in live stacking with just 80 seconds, visibly green. And again, we're just saying one sentence on these just to get our time logged, really. It's what it's all about. M43 was discovered by Jean-Jacques de Marienne, however you say that, sometime before 1731, then cataloged by Charles Messier in 1769, physically a part of the Orion Nebula. It looks like some large power force fell through that planetary. I don't think M43 is a planetary. It's a diffuse nebula. M78, also known as NGC 2068, is a reflection nebula in Orion. It was discovered by Pierre Messier in 1780 and included by Charles Messier in his catalog of comet-like objects. Oxygen burns green, correct. This is neat because, look, we're also seeing another layer of nebulosity here. I know we're at 2 minutes and 20, but let's just quickly show this nebula in Stellarium and zoom in on it. Is that correct? M78, show chart. So it says it's called Casper the Friendly Ghost. Is that right? I don't think that's right. Let's do a find. I'm sorry, let's do a find and say M78. It is. M78 is called Casper the Friendly Ghost Nebula. Well, now it makes sense that I would always say, this always reminded me of like a ghost-like look. And I don't remember seeing that nickname. But look at this nebulosity here. And then when you go back to Stellarium, look at the way we're seeing that nebulosity here around it. And you can see if we hung around, all of this bank of nebulosity would form up, which is pretty cool, huh? It's a reflection nebula. Yeah, I think it is the same, isn't it? It is the same as Casper the Friendly Ghost, according to Stellarium. Okay, well, either way, we've got to move on. Do I have the right? Yeah, I have the right number there. And over here, we did an observation. Now let's stop our live stacking. Did we save a picture of this? Because that's really a cool. Let's stop our live stacking and let's set our time on 3 seconds and maybe, what, 400, something like that, 400 gain. And let's go see this open cluster now, M50. And you can barely make out down there in the lower right of your frame the scope cam. So you can kind of see the telescope is moving. Now this time we hit this cluster pretty much dead on. See that open cluster. Now a lot of people say that open clusters are not as pretty as the other objects like the nebulae and the planetary nebulae and the diffuse nebulae, but yeah, Casper. But I do kind of like a nice open cluster. I do like them. I think I've shared this before with you guys. I think to me it reminds me of Christmas lights. And I think it's just kind of a happy feeling to see that. Snapshot of this. Did we change the name? No. M50 up there. Snapshot. And once it gets that snapshot, we're on to the next open cluster. That's how fast we're moving now. Slew to M47. Change our name up here, M47. You notice we're not trying to change the title slide. We're just leaving the title at Messier Marathon 2023 because of how quick we're trying to move tonight. And that's because we have 110 objects. Well, I know we're not going to get the last one. So 109 objects to go. So a lot of work to do yet tonight. We're on object number 14, and we have to go to 109. And normally we just do around, 10 objects a night in our 2-hour observing time slot. So it's pretty crazy. The effect. Now this is an open cluster. I don't think we hit that. So let's do plate solve. Unless it's one of those clusters that's almost hard to tell from its background. I don't think we hit it. I think we did a meridian flip, and oftentimes on the first or second meridian flip we do have to do a plate solve again to kind of synchronize that part of the sky. M50, the cluster has 508 confirmed plus 109 probable members, and it's around 140 million apparent years old. That's from Stu. Thank you, Stu. Thanks for your willingness to help us. Yeah, we were off 1.15 degrees, which is half of the RASA's length. So pretty far off, but right here now we're seeing this cluster, and it's huge. Let's look at our deep sky image annotation. Wish there was a keystroke to that. So here's M47. There's an NGC open cluster here and another NGC open cluster here. But M47 is one right in the middle. I wish there was a keystroke shortcut for that. So, you know, that is pretty, but I'm sure there are a lot of people that say, why did Messier think this looked like a comet? Well, you got to remember that he was observing from suburban Paris. And this cluster has 508 members, according to Stu, and 109 probable additional. So see, to Messier, when he looked up in the night sky, it just looked like a smudge. And what does a comet look like? A comet looks like a smudge. So, you know, I really don't hold it against him that he thought that this looked comet-like, because I think his telescope was, it was very primitive compared to, I don't mean to insult him, but it was primitive compared to the scopes that we use today. And anyway, we're off to M46. M46 is nearby. And let's see what altitude we are now. We're at about 36 degrees, so that's good. We're staying above the horizon. Now here's a pretty cluster. I think it's pretty to me when it has all these different colors. Now look at that little smudge right there. I know we're not supposed to get involved in that, but don't you think that's a planetary nebula? Let's zoom in. Yeah, look. We're supposed to be seeing the open cluster, but that is a planetary nebula that's for free, I bet. And keep in mind, this is not live stacking. We're already seeing that planetary nebula. Let's go over to Stellarium and take a look at this. Let's see, show chart, and zoom in here. Whoops, I hit the wrong button. It's NGC 2438. Yeah, sure enough, it's 10.8 magnitude, but it showed up in the first 3-second frame here. It's amazing. RASA, I'm a big fan. So what would you say about this, Stu? We have to remember that Messier was observing from Paris. Kevin, thanks for the encouragement, man, but it's the truth. So Stu's going to tell us, I bet, in a minute about M46. In the meantime, I'm going to do a quick observation. Has an estimated 500 stars in the cluster, and it is thought to be 251 million years old. Estimated 500 stars. What we liked about this was all the different gradients, the different flavors, and that planetary is an eye catcher. You have to look for it, don't you? But it caught our eye, and it just looked like a smudge at first. But then we said, no, wait. Look, you can even see the central star, and we're not live stacking. This is a 3-second exposure, and you can already see the central star. That's amazing. Okay, off to M41. Let's take a snapshot of this. M41 is another open cluster. Planetary nebula NGC 2438 appears to lie within the cluster near its northern edge, but it most likely is unrelated since it does not share the cluster's radial velocity. And what that means is it's traveling at a different speed and also at a different angle. So it appears not to have anything in common with the cluster. How do we detect speed? Boy, that's a good question. It started by noticing variable stars, and there were some variable stars that were close enough to measure by figuring the baseline of the Earth's orbit through what's called parallax. You know, measure the distance that the star's background moved compared to the forefront stars, July 1st and January 1st, and so on. And then once you have that baseline, remember who was the famous, was it Archimedes? I can't remember who was the famous Greek geometry whiz that said, give me a large enough baseline and I forget. I might be mixing that up with something else. But anyway, using that baseline, we were able to figure the nearby stars distance, and there were some special stars that changed the frequency of their variation, getting bright and changing their hues, bright and then dim, bright and then dim, bright and then dim, and they became a special class of star. And we found those stars all over the galaxy and, in fact, universe, and we began cataloging them, and they helped us start judging the distance of these stars and their distance, their speed, because of the Doppler redshift. Like the train whistle goes, you know, like the ambulance that goes by, there went a satellite. So this is M41. What do you guys think of this? And maybe Stu will tell us something about M41. A variable, right. Give me a lever long enough and a place to stand and I can move the Earth. Yeah, that's probably what I was mixing up. Pythagoras, yeah, Stu, I was probably mixing up. M41, the Beehive cluster, was discovered by Giovanni Battista Odierna before 1654, was perhaps known to Aristotle, about 325 BC. Incredibly old. Looks like a crown. Well, now that's cool. M41 looks like a crown, according to Michael. The Little Beehive. Discovered by Bautista in 1654, may be known to Aristotle. Very cool. Kevin says, maybe a crown. Somebody's got imagination. That's all I got to say. All right, let's go to M93, or a chandelier, Michael says. There you go. M93. Notice we're doing all these live, no live stacking. M93. And, you know, our different reference books over here, on another night we have more time, Messier added M93 to his catalog in March 1781. It's a smaller and brighter than M46, but it's not as bright as M47. This group is distinctly fan or wedge-shaped. The group has over 60 true members. My impression is that it appears to be more populous, scattered, brighter, and enlarged version of 103 in Cassiopeia. It's an easy object for small telescopes. Under moderately good transparency, this is a naked eye object. M93. What we can do is we can show the chart on this, and we can, it's called the butterfly cluster here. We can back up. I keep doing that. I keep holding down control because in SharpCap you have to hold down control. But in Stellarium you don't. What we can do in Stellarium sometimes is kind of see where we are in the night sky. So we're looking almost due south, and we're looking up at about, 27 degrees, 28 degrees up in the sky. And this is the meridian. It's the south-north line dividing the sky in half. So constellation-wise, this is not a real well-known part of the sky when it comes to constellations. I mean, Monoceros, here's Orion. If you could follow the belt stars, it would aim down at it. Okay, so let's plate solve just to make sure we're looking at the right part of the sky. M93. The cluster covers an area about the size of the full moon. It contains 100 stars, including several red giants. Kevin asks, Doug, what happens if we believe that the Bible may not be an authoritative source on astronomical timelines? Maybe there's some room for some gasp, errancy in biblical timelines. I don't know. That bothers me a little bit, Kevin, but that's probably just because I tend to be a super conservative guy on stuff like that. I almost would rather believe that God created the thing in motion. But I tell you what else, Kevin. Let's look at this cluster for a second, then we'll come back to this. Now we're looking for some of these red giants. Do you think these are the red giants, the ones that are more orangish? I don't have great color vision, but look, those almost have, don't they, an orangey red tint? This is M93. And we're going to say large, the size of the full moon, several red giants, 100 stars. Stu. Stu, you're just like our staff encyclopedia guy. Open cluster in the southern constellation Puppis. That was the last one. You're reading comments too late. Oh, rats, sorry. Okay. I'll try to remember to look for comments every time. Okay, so this is M93. Grab a quick snapshot. And then we're off to M42. I'm sorry, M52. M52, an open cluster in Cassiopeia. Currently about 20 degrees above, 20 degrees exactly. My take is that first battle in the heavens was some first battle, a lot of energy was released, yeah. Of course, I don't mean to be flippant, but I think there's some longer discussions here. Right, Kevin? Yes, Stu. Wikipedia copy-paste king. So, Kevin, here's my thought. What if the Jews who gave us these genealogies would say, now so-and-so begat so-and-so, and so-and-so begat so-and-so, as if they were, you know, a family tree. But what if in Jewish culture, you really didn't have to list every single person in the family tree? And I've heard it said that that's the case. For example, if your dad was a little bit dishonest and he stole the neighbor's goat and he got put in jail for it, you might leave out your dad in the family tree. Not because you're ashamed or dishonest, just because he's not one of your esteemed genealogical forefathers. And I've been told that that was a trait of Jewish culture. So if that's the case, then the thing that we try to make into the clock, which is all those genealogies, really isn't meant to be a clock. It's meant to be more of a cultural study. And Kevin's noting, he's saying, well, for context, I went to the college where Doug taught and took at least one class under Doug. Yeah. So here we've got this M52 here. And we'll say deep sky image annotation. It's a little bit off, but you can see what we'll do is we'll turn it off, and while we look at it, we'll plate solve only. But this is M52 here. And M52 is an open cluster in Cassiopeia, and Stu's going to tell us a little bit about it in just a second. And I'm just going to say, love the way none of these clusters need any live stacking whatsoever. F2.2, gain 400, 3 seconds is plenty. And Kevin adds, wow, that Bible college was 40 years ago. So there's M52. In just a minute, I bet, Stu is going to have us some data about this. We're going to move on to 103. I'm going to put in M52 here and snap a picture. Also, just to help you believe me so that you don't think I'm making this up, there's your deep sky image annotation, M52. By the way, the bubble nebula is right down here. Deep sky image annotation. So there's M52, and now we're headed to 103, an open cluster in Cassiopeia. Stu says, it was discovered by Charles Messier on 1774. It can be seen from Earth under a good night sky with binoculars. And that is M52. So would this be 103, kind of wedge-shaped? Are we close enough that our deep sky image annotation can tell us? No, we aren't. So we might as well go on and plate solve while we look at this. But take a look. It's like a wedge, isn't it? A triangle. M103. Recorded by Messier in 1781 and later confirmed by Messier, M103 is one of the less notable of the open clusters in Messier's catalog. Has a definite fan shape, as does two other objects in Cassiopeia, M52 and NGC 663. In the case of M103, the nearby NGC object presents a small problem. It shows well in a finder scope, and M103 does not. So let's back out to full frame and use our deep sky image annotation now. Yeah, that's 103. So what we're basically learning here from Pennington is you can easily mistake this for a nearby object that's also fan-shaped. Okay, I'm going to do a snapshot of this. And then for the next object, let's just plan on live stacking it and going back to our normal 20 seconds. And the reason why is because it's going to be a little bit more challenging in a 3-second frame. M103 was discovered in 1781 by Charles Messier's friend and collaborator Pierre Messier. It's located between 8,000 and 9,500 light years from the solar system, ranging over about 15 years. So this is coming up as M1. Excuse me, M1. And back on 103, we're going to do an observation on that and say definitely fan-shaped. Do you think it's already slewed? Did we slew to it yet? Because so far, maybe that's because why aren't we seeing movement in the mount? Slew to 103. Oh, it's because we're on 103. Sorry. Slew to 1 is what we want to say. Slew to M1. Sorry. That was just because I was still back on 103 doing that observation. Did that look like a mini or Cassiopeia? Maybe. Stu says the cluster may have 172 stars if including those down to 50% probability of a gravitational tie. M103 is about 22 million years old. Okay, what can you tell us about M1, Stu? This is a supernova remnant, and it's a very special object in the Messier list because it's the only one of its kind. Famous from striking photographs depicting tenuous tendrils against a background of nebulosity, the Crab Nebula is not quite so striking in a telescope, he says. I'm going to say, yes, the mount appears to have settled. The tendrils are photographic details not seen in a telescope, although the main body of the nebula can be observed clearly. In smaller telescopes, it's an easy object with an irregular oval outline, some details notable in instruments 10 inches or larger. In very large telescopes, a great deal of filamentary structure detail can be seen. He says the crab was formed, that's what this is called, the Crab Nebula. It was formed in July 1054 when its progenitor, a star, blasted away most of its mass in a supernova explosion. The event was recorded at several places around the globe, but there are no known European references to the explosion. It is still, and it would be Chinese references, Chinese astronomers. It is still rapidly expanding at the rate of over 600 miles per second, almost 50 million miles per day. Wow, that's a lot. Although created by an event similar, but much more violent than that which creates a planetary nebula, the Crab does not have a typical planetary nebulous form. It's classed instead as a supernova remnant. It's the only one of its kind in the Messier list. And to me, it's fascinating. I don't know how you feel, but to me, it's really fascinating. Okay, so we're going to reset the display histogram and reset the live stack, and then color balance. And then we're going to zoom in on this. First, let's just go to 100% of the RASA's frame. And already, after 40 seconds, you can see those tendrils that Pennington was just saying are not visible. in any telescope up to, what, 10 inches or larger. So it's true we do have 11-inch telescope, true. But look how with just 40 seconds we started seeing those tendrils. Now let's zoom in beyond our optical and start looking at the digital zoom. Conclusion that the creation of the Crab Nebula corresponds to the bright supernova 1054 supernova recorded by medieval astronomers in AD 1054. I think this is just a fascinating object. Let's dial down the rest of the night sky and try to dial up those tendrils. This is 100 seconds. So what you're looking at here is basically a carcass. And it's a carcass of a star that blew up. Now, not every star blows up into a supernova. Don't I remember reading that stars the size of our sun, don't I remember they don't have quite enough mass to be a supernova. Instead, they're going to swell up and then shrink. You know, you got to have a lot of mass to be a supernova. The Crab Nebula was first identified in 1731 by John Bevis. The nebula was independently rediscovered in 1758 by Charles Messier. Messier cataloged it as the first entry in his catalog in 1757, a full 26 years after John Bevis had already discovered it. But they didn't have internet and websites where they could post these things. I think I'm going to do a little screen grab of this, just because I find it so interesting that we can see this after just 3 minutes. I'm going to say this is M1, 3 minutes, 2023, 03:14. Messier Marathon. Let's go ahead and do a snapshot here too, because this is such an interesting object. And then let's go to the next target. And the next, did we do an observation on this? No, we didn't. So let's just quickly say, after just 3 minutes, a sight to behold. Tendrils after 40 seconds. M45. So let's set our M45 and we're going to stop this sequencer and see. We're back on 3 seconds and 400. So now let's go to M45. Slew to M45. Along with some other things during that time, right, Michael? Okay, we're looking at a very large open cluster here. Oh, this is Pleiades. We ought to enjoy Pleiades for a second. You know, we do have to live stack Pleiades just because. Let's live stack Pleiades just for a few. I know we're wasting time here, but it's not really wasting. Pleiades is just so beautiful, live stacked. When you first start live stack, it's got in its memory the thing you were just observing. And so what you have to do is hit the clear button to clear the deck and start over again. M45, Pleiades, also known as Seven Sisters, Messier 45, and other names by different cultures, is an asterism and an open star cluster. Known as Matariki in New Zealand, its rise above the horizon marked the Maori New Year. Cool. The reason that I think it's important to live stack this is because there is nebulosity here. And you don't really enjoy the nebulosity in its fullness unless you live stack a little bit. I was even listening to a Messier Marathon program today, and one of the participants said, why in the world did Charles Messier ever confuse M45 with a comet? It doesn't have nebulosity. And my answer to that guy is, you must not be doing EAA. Because look, after 60 seconds, look at the nebulosity we're seeing. Look at these clouds. They don't show up very well in live scopes. I mean, maybe eagle-eyed observers could see them, but boy, you start live stacking, and this is a thing of beauty. Look at that. After 80 seconds, there's an entire cloud here. So yes, it's a cluster, but it's also what you consider to be a reflection nebula. Right, Stu says reflection. I'm going to sneeze. So sorry. Oh, how can I mute myself so you don't... Okay, I think it went away. Reflection nebulae around the brightest stars were once thought to be leftover material from their formation, but are now considered likely to be unrelated dust cloud in the interstellar medium. Right. So this cluster is racing through interstellar dust. And when it's doing it, it's lighting it up. Backlit style. Kind of like holding a flashlight behind a sheet at Halloween time to make it look ghostly. And that's what we have here. These flashlight stars behind this gas, making it look a little bit ghostly. You can see how it makes a little bitty tiny dipper. Okay, so here's the handle and the bowl of the dipper. And if you go out here, this would even be the pouring spout. Like lights and fog. Exactly, Stu. Did you just think that up? Because that's the metaphor we needed to use. Okay, 2 minutes, 40 seconds. We got to get out of here. Save exactly a scene. Add observation. Halogen gas. Like halogen fog lights in fog. Stu and Michael. This is what you call team sport astronomy. Okay, we already saved a copy of this. We're going to stop the live stack. We're going to go back to normal 3-second frames at 400. Not 4,000, 400. And we're going to head to M36 next. Object number 22. So now we're officially 1/5 of the way done. And we've been working for an hour and 15 minutes. Not bad. We're up at 65 degrees now. Well, 61 degrees. So that's not bad at all, gang. We're doing well. Look at that cluster in Auriga. Isn't that beautiful? Wow. That's awesome. It's big. For context, that's the... I wonder what width this is. Because it looks big to me. Anyway. This is... Stu says, if you're enjoying this live stream, please like and subscribe. It helps the algorithm share this with more people. Missed the name. This is M36. Sorry, M36. M36. Stu, thanks for reminding people about liking and subscribing. That's very kind of you. With each of these objects, we go in and do a little observation panel like this, and it saves the observations. And it also makes a log entry so we can prove that we saw this object during this Messier Marathon. M36, would you say that has roughly, I'm going to guess, pretending I'm counting sheep, 50 members. Oh, Michael says it looks like a giant starfish. Giant starfish. Michael. This is team observing. Astronomy is no longer a solo sport. Okay, well, that's M36 for you. Here we go. Discovered by Giovanni Battista Dierne before he died, before 1654, who described it as a nebulous patch. How about that? The cluster was independently rediscovered by Le Gentil in 1749, and then Charles Messier observed it in 1764 and added it to his catalog. That's cool. Okay, off to M37. M37. M36. Oh, 60 members. We didn't miss it by much. I could get a job counting sheep. It's 4,100 light years distant and 14 light years across. That's M36. Now this is M37. Messier recorded this object on the same day as M36, September 2nd, 1764. Contains 150 member stars and was described by the tireless T.W. Webb as extremely beautiful, one of the finest in its class. Indeed, is a beautiful example of an open cluster, easy and rewarding object, 4,100 light years distant, 25 light years in diameter. It is especially like, what would you call it? Fine-tuned or something. There are lots of little tiny pinpoints of light. Looks like a ringed cone. The ringed cone cluster. Michael. The brightest and richest in Auriga. Hodierna. 500 identified stars. 150 stars brighter than 12.5. Of course, you can't see 12.5, but it's still nice. All right, next we head to, wait, did we take a picture of this? No, M37. Several different colors there, right? Now it's off to M38. Hi-ho, hi-ho. To M38 we go. Look at that. Nice. Also in Auriga. also in Auriga. M38. Large cluster has 100 member stars located within 2 degrees of M36. 100 stars. It has an oblique cross structure. Huh. This Pennington is saying several people have observed the cross. Would it be like this is the long end and this is the cross piece? Resembles a cross. Oh, or an arrow in motion. The arrow in motion cluster. Michael. 100 members, 4,200 light years. 100 members, 4,200 light years, 21 light years across. Yes, it does look like a cross. Okay, M35 is next. Take a picture of this. Snapshot. M35. Older reports almost always mention a cross shape, which seems more pronounced with small instruments. Now we're off to M35. M35. It's another of Messier's discoveries in 1764, easily visible in small telescopes. 120 members, brighter than 13th magnitude. It says a wide-angle view of M35 with an aperture of 10 inches provides a most rewarding view. Well, there you go. There's a wide-angle view in a 11-inch telescope. On very dark, clear nights, M35 can be detected with naked eye. And anything less, it looks like a sort of a faint patch. Curving rows of bright stars which give impression of rows of glittering lamps on a chain. Wow. Fainter stars from a sparkling background with an orange star near the center. Look at that orange star. Let's go in and zoom in on that. Is that the orange star? It's beautiful, isn't it? M35. Scattered over part of the sky almost the size of the full moon and 2970 light years away. (2,970 light years distant, scattered over the width of a full moon. True with 18 light years. M35. Now we'll head to M48. There are 305 stars that can be intrinsically shown to be extremely likely to be members and up to 4,349, averaging 50% membership. My goodness, that's a lot. Or an elk. Ah, the elk cluster. I'm going to edit the observation and add that. M35. Edit observation. The elk cluster. Michael. Haha. That's fun. Okay, M48, here we come. For context, let's show chart on M48. So we're looking due south again, almost at the meridian. We're at 46 degrees above the horizon. And again, this part of the sky in the south, you would have to decide if it's a part of the sky that you know very well. Here's Hydra, not the one in the James Bond movie. Or was that Captain America? Can't remember. Captain America, maybe. But here's Canis Major, and there's Sirius. I'm Sirius. It's just a hop, skip, and a jump from Sirius. Here's a constellation, Pyxis, Antlia. I mean, I've never observed things in these constellations, I'm so sorry to say. But it's nevertheless important to get there during the Messier Marathon to see M48. Discovered by Charles Messier in 1771, but there's no cluster precisely where Messier indicated. He made an error as he did with M47. Excuse me. The right ascension matches, but the declination is off by 5 degrees. So as a result, the cluster is sometimes attributed to Caroline Herschel in 1783. This is M48. Where is it? Pray tell. Over here? We're plate solving. We must have done a meridian flip. Kevin, thank you for helping me with that. Hydra is in the Marvel universe, not James Bond. So sorry to insult all those Marvel fans out there. So sorry. I think this cluster is going to be this one over here to the left. So we're doing a quick plate solve since we probably did a meridian flip. A meridian flip means the telescope turns with its weights in the opposite direction. So yeah, here we go. Here we are. This thing is dominant. Look at this, how big this is. 2,500 light years from the sun, 400 million years old. James Bond was Spectre. Thank you, Stu. What a beautiful cluster. Wow. This is huge. This is, I've got the RASA backed all the way out. This is huge. 2,500 light years from the sun, 400 million light years old. Huge. M48. Well, 54, so half a degree wide. No, wait, 50, almost a degree wide, sorry. 60 minutes in a degree, so almost a full degree wide. Visible naked eye under good atmospheric conditions. Brightest member is the star Hipparchus 40348 at a visual magnitude of 8.3. So it could be that one. Awesome. That's M48. And now we head to M44, the Beehive cluster. M44, again for context, we'll show chart. There you go. The Beehive cluster. It's in Cancer, not a state of disease, but rather the constellation. So there you have it. Here's Gemini and there's Leo. So you got Leo, Cancer, and Gemini all together. Wow, look at that. It's another huge one, isn't it? Wow, so this is what, M44? It's a full degree. And it's also called Pricepe. 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 Pricepe, or the beehive. Remember we looked at one a while ago, it was a little beehive, I think. Naked eye, 1 degree wide. 350 member stars. One of the closest open clusters to Earth. Oh, Pricepe is Latin for manger. Larger population of stars than others nearby. 1,000. That's a lot. We haven't seen anything near that, but it's so big, isn't it? You know, obviously you can see why they call it a beehive. It just looks like a swarm, doesn't it? M44. And next is M67. Has been known since ancient times. Classical astronomer Ptolemy so. Described it as nebulous mass in the breast of Cancer. It was among the first objects that Galileo studied with his telescope. And Michael says, yes, it does look like a swarm. It's well named. Appreciate you guys being with us on the live stream. We have still about 15 with us. Even though we're getting later and later, thanks for sticking with us. Tonight, as you've no doubt noticed, is Messier Marathon night. At least we're trying it. And the attempt we're going to make is at least 109, probably 109 stars. And we're glad to have you here. If you like this kind of content, please do consider clicking that like button, the thumbs up, and subscribe. We'd love to have you subscribe as well. It helps get the channel up, and it doesn't cost you anything. It helps put it in other people's heads-up radar. All right, so this is M67 in Cancer. And M67 is fair-sized, half the diameter of the moon. It's rich, with 500 members. Stu says, also it's known as NGC 2682, sometimes called the King Cobra cluster, or the Golden Eye cluster. Now that's James Bond, isn't it? In Cancer, discovered by Kohler in 1779, who's famous for making all the faucets in public restrooms. So that's M67. All right, we're ready to go to Leo and look at galaxies. So let's go on and switch now to live stacking, because I think we're going to need it and want it for these galaxies. But let's try it first. M65, slew to it. More James Bond. M65 is a galaxy in Leo, and it's actually famous for being the Leo triplet. And I didn't think we'd be able to see this. Let's show the chart here real quick. And tell you what, let's do. Can Can we get that star? Right there. Now let's slew to that star, current object. Because we want to be sure and catch all three of these really well. So what I'm doing is picking a star in the middle of all three. And let's turn on our field of view. Oh yeah, no problem. So now let's go back and yeah, you can make them out. Look, here's one, and there's one. I wonder if we lengthen this to 7 seconds, for example. Rather than live stack, let's just attempt to get this live. Yeah, look, we don't need a live stack. The Leo triplet, who knew? If we go to 10 seconds, then we'll be able to see it really well without even live stacking. Okay, so this is a Leo triplet, and we should be able to do the we need to plate solve only. I think this is the one called the Hamburger Galaxy. NGC 3627, I think. Yeah, oh, that's 3628 is the Hamburger. So M66 is 3627. M65 is 3623. So in just a moment, there you go. So this is M65 here, that's M66 there, and then that's not got a Messier number, it was too faint for Charles Messier. So let's remember that M65 is up here, and that's M66. Now let's turn off plate solving. I mean, deep sky image annotation. Boy, look at all those galaxies. This is an entire minefield of galaxies. M65 and M66 right here. So we're going to say part of the Leo triplet with M66 and NGC 3628. NGC 3628, the Hamburger Galaxy. Can't get over the fact that you can snapshot M65 and 66. Right, each rate is constant. It's a brand new 10 second. Oh, yes, so each galaxy moves at their own rate. Well, generally that's true. I don't know if these are moving together or not. Maybe that's something we might be able to look up with M65 and NGC 3628, the Leo triplet. Okay, off we go to M95, and we're at 10 seconds. This is another galaxy, so we might have to stack this one. Well, let's go ahead and slew to it and see. Because the ones that we can do with pure live stacking, without live stacking, we're certainly saving time. If we can do that. Boy, right there it is in the middle, but we're not going to see it as a galaxy, so we better go back to live stacking. So we're going to go 20 seconds and 100. and then live stack. And then clear. And this is M95. M95. Reset the display histogram, and then reset the live stack. Our reds are just out of control, so let's try the color balance again. There we go. And move the blacks to right about there, and then bring up the mids and zoom in on this. There we go. Now we can already see some structure after 2 frames of 20 seconds each. So you see we're starting to see a bar, and we see an outer ring after 40 seconds. This is M95. Is a barred spiral 33 million light years away in the zodiac constellation Leo. Saw the bar and the outer ring after 40 seconds. 33 million light years away. Right, Stu's pointing out that the universe expansion is accelerating and that things are supposed to expand in different ways, but you know, like a cluster moving together, I wondered if these galaxies, because they're a triplet, are they gravitationally bound? And maybe because the 3 of them are gravitationally bound, maybe in general, they're traveling together as a galaxy group. That's what I wondered. So, let's see. I don't know offhand if these are bound or if they're just optically aligned. We'll have to look that up. While this is stacking, we're at 2 minutes and 20 seconds. We don't have time to look that up, unfortunately. But we'll have to look this up on another night. Is the Leo triplet gravitationally bound? That's what we'll want to look up. This is certainly a fainter Messier object. Hats off to him that he saw it. That's 2 minutes and 40 seconds, and there's 3 minutes. So we'll snap our picture. That is looking a lot like a stirring implement for a 5-gallon paint bucket. It's got the bar and the ring clearly seen, isn't it? And now let's go back to our sequencer and use the default for the next target, which is M96. M96. Probably not that far away. M96. To the eye, M65's disk appears slightly warped, and its relatively recent burst of star formation is also suggestive of some external disturbance. The astronomer Roth, R-O-T-S, 1978, Roth, suggests that the 2 other galaxies in the Leo triplet interacted with each other about 800 million years ago. So they might not be gravitationally bound. Okay, so this is M96. And it's very faint, isn't it? M96, discovered by Messier, same time as M95, elliptical appearance is, brighter than M95. No, novice observers might confuse 96, 95. 95 is fainter and elongated. Wow, so this is supposed to be... Oh, we weren't settled yet. Oh no, this is the sequence. I mean, this is the plate solve, I guess. That's why it moved a little bit. So I put it right in the center for us, so we can make sure it was M96, right here in the middle. That doesn't look very bright to me. Intermediate spiral, 31 million light years away in the constellation Leo. Intermediate spiral. There it is. 31 million light years away. Brightest of the M96 group. Nine other galaxies. M96. Look at these other galaxies here. Let's turn on deep sky edge annotation. Okay, so that's M105 right there. And two NGC galaxies. Oh, you know what? This is bumped over. That's M105. It's just slightly misaligned. M105, NGC 3384, and NGC 3389. So there's M105. This is M95 up here, the one we just looked at. Yeah, so there's 95, 96, and 105, wasn't it? Yeah, 105. Let's do 105 while we're here. Easily seen with 96 and M95 in the same frame when centering on M96. M105, coffee time, Stu. 105, one of Messier's discoveries. This object is not on Messier's original list, although he observed it sometime between 1785 and 1786 in his logbook. It's one of the smallest objects in Messier's catalog, very nearly round, and there are two other similar smaller spindle-shaped galaxies in the same view, 29 million light years. So 29 million light years from Earth. Lots of dark spots in that picture, yep. Let's zoom in on this a little. And we're going to let that collect and let you guys admire it. And you've got the music there. Let me turn up the music for a second. Where is the music? Is it right here? And we're going to do a 5-minute break, quickly. 5-minute break. Okay, I'm going to try to get the music a little bit better balanced. Stu, I really appreciate you. Really appreciate you saying that. Tell me if that's right, Stu. I never know for sure what balance to use because I am not in a separate room from myself. So it's very difficult. Even with headphones on, I've tried. It's very difficult to know how to get that balance. Tell me if you think the music should be up just a little bit louder. And if my voice is up now enough, please help me understand. Okay, so this is now at 8 minutes. I try to take a 5-minute break every 2 hours just to grab something, some kind of snack or something to keep going through the night because it is a long night and would encourage you guys to do the same. So when Stu went and got coffee, I knew that was time to go grab crackers. Okay. All right, so now we're testing here. I had the receiver gain turned down a little bit on the mic input that I use, but now I've got it back up. Tell me if that's over-modulating yet. Coffee's still brewing. All right. So this is now M96. Let's go back and just get our bearings again. Show chart, M96. Okay, that was M96, M105. Okay, so this is M105 here. And we're ready to move on to some globular clusters. So let's save this image as seen and get back in the saddle. Whoops, yeah, that's right, M96. But it's also 105. Same frame. So this is our 33rd object. And for reference, we usually do 10 objects in a 2-hour live stream. And it's now been 2 hours and 5 minutes. So we're really doing great on covering ground, gang. Thanks for hanging in there with us. Okay, back out to auto. Let's go back down to 3 seconds. Somebody, when you get a chance, tell me if that music is the right volume now, please. And if the voice is the right volume, when you get a chance. Okay, here we go to M105. No, M3. Stop live stacking. And slew to it. Those crackers are good. These are Triscuits. Highly recommended on Messier Marathon nights. Triscuits. Thanks, Penny, for packing these. M3. One of the 3 brightest globular clusters in the northern sky. Right there it is. Globular clusters are a little bit different because they, as you can see, they have a central core, and they revolve rather around the Milky Way, for example, outside the disk in like random order. And there aren't that many. It seems to me like, I think I remember reading there were 150 globular clusters in all of the Milky Way. But I think they're beautiful. They look like a snowball to me. Trying to mute myself when I chew on the cracker. One of the three brightest globs. M3. So for context, we're now looking east-northeast. And we're right above Boötes, right above Arcturus. This is at 21 degrees, 28 degrees. Snowflake, yeah, good idea. It does look like a snowflake. All right, let's go to M53. And M53, close by, same general part of the night sky, up from Arcturus in the east. M53. This Messier added this cluster to the first supplement to the famous catalog in February 1777. Bright and condensed, this globular is easily seen in small telescopes. Partial resolution is achieved in telescopes of 6 inches and is easily resolved in large telescopes. You've got to make sure you don't confuse it with a nearby cluster. I don't think we would have confused it. It's the only cluster in our field of view. It is a beauty. Looks like our focus is starting to change. Let's check our temperature. 27. Huh. We're definitely not. Of course, we're at 200% there. So that's part of it. We're overstretching our optics. That's 100%. That looks better. Okay, so this M53, 65,000 light years. 65,000 light years has the luminance of 200,000 suns. So we're well past a third of the way now on our journey through the Messier list. Hopefully, the majority of it in one night. So let's switch to our next target and let's try it. Let's see. Let's try it without plate solving, just out of curiosity. And it's M64. M64. M64, the Black Eye Galaxy. Messier found this large oval spiral in March of 1780. In the Shapley-Ames catalog, it is rated as one of the 12 brightest spirals. It is a spectacular sight in telescopes of large aperture at high magnification. Its central feature is a dust lane along the north and east side of the central oval mass, giving the Black Eye nickname. The dust lane can definitely be resolved in telescopes 6 to 8 inches and may be glimpsed in instruments as small as 4 inches. 30 million light years with a true diameter of 48,000 light years, it blazes with an energy of about 31 billion times that of the sun. I think maybe I forgot to stop the live stack. That's what's making this mess. And this is M64. Yeah. Seconds at 100. Did we did this plate solve already? Because I think our cycle got interrupted. M64 Black Eye Galaxy. Yeah, that was a mess of light, wasn't it? I think I had forgotten to we were on the 3-second exposures at the high gain. And then we started slewing and had that all mixed up with, we were still live stacking. It was a mess. So we'll get this straightened out. We were 0.23 degrees off, so I'm glad we did this plate solve so we can put this right in the center of our frame. Okay, now let's start live stacking. And it's M64. Oh, now look, that's the same. Oh, maybe we have to clear our live stack. That's what it is. There we go. Takes it a while to clear sometimes. Oh, you were talking about the 300 billion brightness of the sun. You're right. There it is. Yeah, it's already decent looking after 20 seconds. I always think this looks like a hippo that's almost fallen asleep. It's his hippo eye, and he's just nodding off. It's beautiful, isn't it? 30 million light years, 30 million light years away, 48,000 light years diameter. Boy, these distances, just don't take that for granted. 30 million years ago. Okay, I gotta get on my kick. 30 million years ago, the light left this 48,000 wide object. And somehow, by hook or by crook, these photons, which travel in packets and waves, the packets are in waves toward us, but they're discrete packets. Somehow, it managed to travel toward us in the vastness of space and not hit anything else yet until tonight at exactly 11:04 p.m. Eastern Time. It hit the mirror in the back of the RASA telescope out there. And when it hit the telescope out in that observatory and bounced up into the camera sensor and was converted into a different kind of photons that we could see, it was the first time in 30 million years, apparently, that these photons had been stopped by anything. And here's the problem. Nobody else will ever see these photons ever again. We interrupted these photons on their journey, and we've captured them. A piece of the universe that came from 30 million light years away, we captured it, and now it's gone forever. And I go through phases in which I think, how selfish of us to capture this. And then I think, well, you know, if we hadn't had our telescope out there, they would have hit the dirt, and then nobody would have been able to see them. So how bad would that have been, right? So there you go. M85 is next. M85. That was M64, Black Eye Galaxy, Stu. And now this is M85 coming up. Michael thought it looked like a cat's eye. Yeah, nobody would have seen them. Cody's Lab, how far are the nearest stars on YouTube? Awesome video for understanding the scale of solar system and galaxy. Yes, you're right, Stu. You told us about that, and I actually went and watched it. And you're right, it was really good. Cody's Lab. Okay, so this is M85 coming up, also known as NGC 4382. It's a spiral galaxy in Coma Berenices. Although actually located within the border of the constellation Coma Berenices, this galaxy is a member of the Virgo cluster. Many Messier Marathon charts and lists group this object with those in the Virgo sequence, but Pennington has found that this galaxy is much easier to locate by using Coma Berenices as the constellation to find it. Discovered by Messier's associate Messier in 1781 and described by Messier later in the same year, well-defined oval. 44 million light years, estimated the diameter at 40,000 with a total mass of 100 billion suns. Is that it in the middle there? Boy, it's not really looking like much yet. M85. Part of the Virgo cluster. 44 million light years away. Oh, there it is. Oh, you've got it at 60 million. 44 to 60 million light years away. I trust your source better than mine because mine's dated. 125,000 light years across. Stu says, stupid far away. Let's see. It's a companion, isn't it? So this is M85. I remember these, yeah. M85. We've seen these before, haven't we? Show chart. These are kind of like really cool the way they're sort of eyes, like looking at each other, kind of. Isn't that cool? M85 with NGC 4394. Companion to NGC 4394, like gator eyes or something. Very complex outer structure with shells and ripples that are thought to have caused by a merger with another galaxy took place between 4 and 7 billion years ago. Nice. So this outer structure here is what you're talking about, Stu, isn't it? That kind of outer fluff. Let's hold down our shift key and darken the sky just a hair so we can make that outer layer out a little more. That's the best we'll get it right now in 2 minutes and 40 seconds, but we have to push on. Since it's Messier Marathon night, but this deserves more time. So Messier 51 is next. Messier 85 should contain a central supermassive black hole of around 100 million solar masses. Velocity dispersion observations imply that the galaxy may entirely lack a central massive black hole. Wow. So it's missing its center. Whatever happened to its black hole? Those things don't just disappear. Ah, something, maybe there was a, I know, when it did the merger, it interrupted the black hole. Maybe it merged with another galaxy, and that other galaxy's black hole swallowed up this black hole. How about that? Boy, there are tons of objects still available. When is this gap? When we're supposed to run out of things? It looks like around object number 82 or so. We're a long ways from there. 30 objects at the rate we were going, it would be another 2 or 3 hours from now. It's going to be a long night, guys. Stole its black hole, right? I know, bring on the nebulae. It's a super merger, Michael says. That's great. I don't think we're going to have time to plate solve all these. It's just too time consuming. We're going to have to, by faith, oh my goodness, look at this. This is beautiful. Oh yeah, this is M51, of course. The Whirlpool Galaxy deal. The question mark galaxy. Wow, look at that. That is amazing, isn't it? And never, this particular galaxy pair never ceases to amaze me. Mid-afternoon for you, Stu. Yeah, Michael, I think you're right. How did Messier find all these? I think he just had a Wasn't it just a 4-inch telescope? I mean, I don't think it was huge. Seemed to me like it was 4-inch equivalent. Okay, so for context, we're east-northeast, and we're up about 40 degrees. This is between Boötes and the Big Dipper. So to find M51, you could just go out the handle of the Big Dipper and then drop right below the handle. But look how it's got this cool, I don't know. This could be a lizard, and he's got his tongue out, and he's grabbing this lightning bug here. Look at all this nebulosity. We're not going to see all this tonight, I bet, because we don't have time to hang around. But we're seeing quite a lot of it, aren't we? Let's dial up our mids a little and see if we can... No, this is about all we can push right now, but 2 minutes and 20 seconds. What a cool look, huh? Had a mate that found a lot of them. Yeah, Messier. Michael says, yeah, M51 is most impressive. We're starting to see a little bit of this nebulosity here. That's 2 minutes and 40 seconds. Yes, now we're seeing this. Let me dial this up a little more. Yeah. See how it's just faintly beginning to show up. All of this faint. Now that, I don't think we're seeing that tail thing yet. Maybe, just barely. This deserves more time. That's 3 minutes and 20 seconds we have to go. But wow, I'm going to do a little screenshot of this. Because that is so cool. M51, 3, we might as well, yeah, 3 minute, 40 seconds on 2023-03-14 Messier Marathon. Very cool, we'll save that as seen. I'm loving that. Woohoo! That's nice. Okay, let's do the next. Let's try to do the next target without plate solving. And lots of cool nebulosity off the end of the companion. First galaxy to be classified as spiral, STU, 31 million light years from Earth. It did have a green tinge tonight, you're right, and I don't know if that's just the color balance that we just let it auto balance. We weren't messing with those colors at all. That was just the auto balance. The next galaxy is 101. Do all galaxies rotate the same way, like clockwise or counter? No. They're all topsy-turvy, angled all different ways. Because they're not in a plane, you can't depend on anything, being synchronous. They're all mixed up. Why didn't this clear? That should clear automatically. because in this sequence all I took out was I took out the plate solving, but I didn't take out the clear. Maybe it just hadn't had time yet to clear. This is M101. I think this might be called the pinwheel, isn't it? Face-on pinwheel. Look at that, it still didn't clear the plates, the live stack. Maybe we didn't slew yet. You think? In which case, we're really going to be mixed up. We got to step up our game here. That's taking too much time. Looks like we're settled. Okay, here we go. See any galaxies there? Waiting just a minute for this silly 20-second exposure. I don't think my sequence is correct. That might be right there in the middle of it. Now it should clear. I just hadn't slewed to the new target yet. Crazy. Like a fishbowl. The only constant over the whole universe is chaos. A large fishbowl. A very large fishbowl. Waiting a whole 20 seconds for light that's traveled 50 million years. That's right. Okay, so let's get this show on the road here. And then this. And then that. Yeah, this pinwheel. There's something out here. I wonder what that is. Oh, isn't that a beautiful structure? Wow. That's NGC 5474. It's another galaxy. Okay, for context, we're northeast, and a while ago we were off like below the handle. Now we're just above the handle. To me, this is one of the best galaxies ever. It's just classic spiral with all those arms. I mean, look. You've got this arm wound out this way, and then a matching arm wound out that way, and then you've got an arm off an arm. So this arm, that arm. Let's go a little bit to the left here. Just fine-tuned. Arms off of arms. The Pinwheel Galaxy is a face-on spiral 21 million light years away, and I bet you're right, planets everywhere, Michael. NASA and European Space Agency released a very detailed image of the pinwheel, the largest, most detailed image of a galaxy by the Hubble Space Telescope at that time, 2006. Look at out here, all these stars out here, star forming regions, I bet. So many arms and stars forming in them. Amazing. 51 individual exposures plus some extra ground-based exposures. We wanted to stay longer. I'm going to look real quick at this sequence. This is next target without plate solving. Set the display zoom level, stop live stacking. Set exposure to 3 seconds, set gain to 400, prompt enter the next target name, set gain to 100, set exposure to 20 seconds, start live stacking, wait for 2 seconds, reset live stacking, wait 21 seconds, reset the display stretch, live stacking, auto white balance, auto stretch display, high progress. This should work. There's nothing wrong with that. Okay, so let's try it again. Let's, right here, let's, that's the wrong one. Oh well, we'll live with it this time. 106 is the next target, M106. M106. Haven't got time to see it, but well worth a look later. You're right, the Hubble view of that? Yeah, we should. M106. Yeah, I chose the wrong sequence. It's doing a plate solve again. 106. Another of Messien's discoveries that was not found in time to be included in the last supplement to Messier's catalog. If the old Ferret of comets had lived long enough, the numbers 104 to 109 might have been included. It is a large spindle galaxy that is easily seen in small telescopes. 25 million light years, has about 100 billion suns. Have we slewed? Must be it right there. I'll have to watch and not choose that plate solving solution every time, because that's definitely taking up time. But it does give me time to mute my mic and take another cracker. So for context, am I still quiet? Wow. Well, that's actually turned up all the way there, but I could turn the music down a little more. Let me look at settings. audio settings and see if there's anything else going on here. Microphone. Doesn't look like there is anything else to adjust there. And it's turned up all the way. I am speaking more softly. Receiver gain. Settings. Transmitter gain. Oh, I have 2 more decibels here. I could go up there. Okay, looks like that's the most I can give. Is that better? Yes. Okay. We're pointing northeast now, just right above Canis Venatici, still in this region underneath the Big Dipper handle, for context. And wow, look at that. Let's see, let's reset this display histogram. And then reset and auto stretch the main histogram, and then auto color balance, and then dial up the mids. That's 2 minutes and 20 seconds already. And this is M106. It's beautiful, isn't it? Wow. Water vapor mega maser, the equivalent of a laser operating in a microwave instead of visible light on a galactic scale. Oh no, I don't have family here. I'm at our office, so there's no family at all. I'm not at the house where I live. There's no one else here in this entire building. So M106 has a water vapor mega maser. Are you making this up? The equivalent of a laser operating in the microwave instead of visible. Oh, you mean microwave wavelength, not inside your microwave in the kitchen. And on a galactic scale. Thanos. That's some kind of superhero, I think. Beautiful 45-degree edge-on spiral. Pronounced bars. I guess that means lots of alcohol. I'm sorry. Probably shouldn't say that. It is beautiful, isn't it? Wow. I know this is 4 minutes and we should leave, but look at that. You can just almost imagine the water maser like a big fire hydrant. I love that. That's M106. Okay, now let's choose wisely here. We're going to go to next target without plate solving. Okay. M106, and now we go to M40. Oh, it's a double star. We don't even need to plate solve. I mean, we don't even need to stack. This is M40. It's a lame, I'm sorry, I shouldn't say any of these targets are lame, should I? But this is a lame target, M40. I'm going to stop this because we won't have to plate solve this. Please stop. Boy. Okay, finally. And we're going to set this on 3 seconds again and set this on 400. The pair were discovered by Charles Messier in 1764 while he was searching for a nebula. He had reported in this area by Johannes Hevelius. Not seeing any nebulae, Messier cataloged this apparent pair instead. Lame. He added them because he couldn't find anything cool in the area. Yeah, that's exactly my thinking, Stu. You are on it. You're reading my mind. No offense to Messier, but what was he thinking? I can't find anything interesting, but here are 2 stars. How do you say that with a French accent? Why won't this thing go away? I can't. There it went. Finally. All right, so I guess we better figure out which 2. That's the craziest thing ever. Show chart. So there are 2 here that are closer to a third. And then there are 2 here that are just solo. So here are the 2 that are closer to a third. And this, believe it or not, is M40. Oh my goodness. No offense, but this is such a lame Messier object. Apparently, Messier had heard that there was an object in this general area from Johannes Hevelius. Not finding it, he cataloged these 2 stars. And all of us trudge headlong forward like lemmings, observing his, what do you call it, mistake? All over again. One of the few real mistakes in the Messier catalog, faulting Messier for including it when all he saw was a double star, not a nebula. Crazy. Faux pas, right. But anyway, there it is. It's a beautiful double star. Okay, so that's M40. Now we go to M81, M82. This is Bode's Galaxy. Boy, I bet we're going to want to stack this. Well, let's salute to it first, just to see. M81 and M82. I mean, Bode's Galaxy is cool. A French mistake. You know, in my, what do you call it, OBS? What does that stand for? Online broadcasting software? I don't know. They've added a thing that now tells us how long the stream has been going. I like that because prior to this, I could never remember how long we've been going, but now it tells you precisely 3 hours and 39 minutes so far. It tells how much of the CPU is being used, how many frames per second you're uploading to YouTube, what's the kilobyte per second speed. I like it. Okay, so we're going to have to live stack this, aren't we? There's just no doubt about it. So let's change this to M81. And by the way, let's go look first at this screen before we start live stacking. M82, but the Garland Galaxy is just NGC. So these should be in our frame, M81 and M82, a 2-for-1 special. That must be it right there. So M82 is the cigar. You know, we really don't need to live stack them much, do we? Let's set this on 20 seconds though, just so we do this right. And this on 100. Don't need to plate solve. And let's start live stacking and clear our live stack, because it'll be messed up. In late February 2022, astronomers reported that M81 may be the source of FRB 2020-0120E, a repeating fast radio burst. Aliens! Oh wow, look, that was with 20 seconds. That's super cool. This is this Garland Galaxy here at the bottom. So M82 is this cigar-shaped deal. Boy, look how it's got this funny, opposing, weird thing going on here. Like a dust lane right there. And this is just a gorgeous spiral. I mean, if you were to design a spiral with some kind of computer software, it might look like this. Trying to bring the sky a little bit darker to increase the contrast and see. That's 80 seconds. Wow. Bode's Galaxy is a grand design spiral galaxy about 12 million light years away in the constellation Ursa Major. FRB are so cool. FRB. Freight red bananas. Messier 81 was first discovered by Johann Elert Bode on 31 December 1774. In 1779, Pierre Michin and Charles Messier re-identified Bode's object, hence listing it in the Messier calendar. Mike, Jerry, woohoo! How are you, Mike? Fast radio burst, gotcha. Faint radio burst. Mike, yes, we're committed to doing the whole list. Now, if we can get ahead by that 3 a.m. gap and take 2-hour nap, I won't be afraid to take the 2-hour nap. But we will leave the broadcast running, and after the 2-hour nap, we'll get back on for the ones that rise later. You remember how that goes. You've done this with us before. 2 minutes and 40 seconds. M81, I'm going to put a dash here and say M82 and say save as scene. And for the M81 observation, I'm just going to say amazing grand spiral. Yeah, I bet you do, Mike. And then for M82, we're going to say Quantum Space, good to have you aboard. Yes, thanks for asking, Quantum Space. We're using the Celestron light pollution filter that was designed and made specifically for the RASA 11. It's an expensive filter, and some people don't like it, but it's the one I have. It's very expensive, and it does, I think, do a reasonably good job with our Bortle 6 skies here in Louisville. This is Cigar Galaxy. Everything hung on me getting the Phantom. And according to you guys, I did. Yeah, that's right. We imagined it was there. Stu, what you got on M82? 16,000 light years diameter. 50 billion suns. 16 light years diameter. 50 billion suns. That does not mean that it has a lot of boys. It means a sun like our sun. All right, let's save this one more time because this is a fun picture, isn't it? And then let's go to the next. Something is still not right about this sequence, but I don't know. Let me see. Prep for imaging only. Let's try that. And then let's go to this planetary nebula, M97. That was not the right. Sequence. Hello. Stop your sequence. M97. Oh my, look at it. We don't need to stack it. It's beautiful. But it will look better stacked. Can you recommend a light pollution filter for Hyperstar? That one is designed for RASA. Mike, you might remember, if you're still on, Mike, you might remember the one that Frank likes. I don't know, I don't think Frank is still on. But Frank, I think, has a Hyperstar, and he bought an expensive one that he really liked a lot. The Owl Nebula. I'm thinking it's got a sound like, what is it? Hyderbaz. Mike doesn't recall. Hyderbaz. What is that called? We're at 60 seconds, so let me sneak out and look real quick. Fast light pollution filter for Hyperstar. And are you looking for, this would be 2-inch, right? Quantum space? So you'd want one that's high speed. But you wouldn't want 1 1/4. You want 2-inch, correct? I wonder if that's it. NBZ. Optilong. IDAS, that's it. I remembered it had that DAS at the end or something. IDAS, IDAS. 2400. Okay. This is slow loading, but it could be because I have a zillion things going on here. Tech IDAS MBZ ultra high speed 52. Boy, $329. I'm almost sure that was it, but boy, don't order it. But you could call High Point and say, is this the right filter with my Hyperstar? And they'll confirm whether or not it is. I'm pretty sure that it does have that sound, IDAS, in it, that the guys were saying they really liked. But I'm not really a good source because I don't have a Hyperstar, and I just decided to buy one filter and stick with it. So I've never really actually tried other filters. So I'm the wrong guy. Okay, this is 3 minutes and 40 seconds, so we're going to save a scene. And it's a starburst nebula, approximately 2,000 light years away, 2030, in the northern constellation Ursa Major. Estimated age is 8,000 years. So we're going to say cool greenish owl nebula, 20-30 light years away, 0.13 solar mass with density less than 100 particles per cc. And Antilia tri-band RGB, Mike says. So you could investigate that quantum space. Thanks, Mike. IDAS makes lots of filters. MBZ is a narrowband, not just for light pollution. Okay. They're liking the Antilia tri-band RGB for light pollution. But you got to make sure it's custom for the Hyperstar, because you know that speed is a problem if you get the wrong speed filter. All right, let me see if I can do the right sequencer this time. I did. Here it is, next target, that's what we need. Now we've got a bunch of galaxies in a row, and I fear that these are going to need to be live stacked. Let's try it. M108. Yet another of the objects added to the Messier catalog in recent years. The galaxy seen nearly edge-on is fairly bright, will appear somewhat spotty or mottled in larger telescopes. In smaller scopes, it will appear as a small cut of light with a brighter middle section. There's no central bulge. 35 million light years, mass of 14 billion suns. So this is M108. Oh, it's plate solving. So that's not the one we wanted either. We want to try to do these without plate solving just to maximize our speed. Yeah, Mike is saying he's not sure that Antlia is good down to F2. That's what you really have to check. Since the Hyperstar has been around for a while, I'm pretty sure somebody like Agena-Astro or High Point will be able to recommend the best deal. But boy, it's going to be, I'm sure it's going to be above $200. You know, it's a shame. But this Celestron light pollution filter for this RASA was more than that. And I just decided, you know, it's going to be out there, and I'm not going to go back and forth and switch filters. I'm just not going to do it once. And another reason I'm not going to switch is because of how hard it is to get the RASA tuned, you know, because of that problem with tilt that RASAs can have. So I just said, I want to install a filter for life. And that's what I've done. I just left it on there for life. I never touch it. I don't move the silly Octopi-Astro camera interface a bit. Look how close this is to that Owl Nebula. It's in the same frame. Crazy. And we don't really need much time. This is 40 seconds. I'm going to drag this over right there. What an odd looking galaxy, isn't it? M108. $35 million light years, 14 billion suns. It's a lot of suns. $35 billion light years, 14 billion suns. Michael, you're nice to encourage. This is a strange looking edge-on spiral. Maybe we're seeing it through its outer dust lanes. Super strange. I don't know if these stars are in the foreground. It looks to me like these stars are in the foreground. So if we can pretend that those foreground stars are not there, and then just look at this oblong lens, what a strange looking spiral, huh? Surfboard galaxy, Stu says. Surfboard galaxy, Stu. Barred spiral. Well, it's certainly memorable because it's so different. That's 2 minutes and 40 seconds, and we're going to call it there. So let's don't do a sequence right now. Let's just stop live stacking and switch manually to 3 seconds here, and switch this manually to 400 gain, and try just going manually to the next galaxy, which is 109. 109, the final discovery of Pierre Messier 109 was added by Owen Gingrich in 1953. Its oval appearance is unmistakable. It's very close to Ursa Majoris Fad, the southernmost star in the bottom of the Dipper's pan. Brighter central portion will be discernible in smaller telescopes 38 million light years away. Well, let's see. Let's just try a 20-second frame at a gain of 100 and just see what happens without live stacking at first, and see what the snapshot looks like. So this is 109. I thought that was funny a while ago, Stu, when you said, here these things are 38 million light years away, and it seems like a long time to wait for the 20-second exposure. Oh, I've got it on 106%. Let's back out to auto. Oh, we are going to have to live stack this. And this is 109. Isn't that funny that you can take a 20-second frame and see nothing, but when you turn on live stacking and it captures your first 20-second frame, you see something. This is a star that it said it was close to. That's the bottom, the southernmost star in the bottom of the Dipper's pan. It's called PHAD, P-H-A-D. So what we'll do is we'll say show chart and go here, and they pronounce it P-H-E-C-D-A, FECDA. It's the vacuum cleaner galaxy, but of course, it is the bottom star of the Dipper's pan for context. It's the vacuum cleaner galaxy. Why is it called the vacuum cleaner galaxy? Doesn't look like a vacuum cleaner. Now it does. Look, there's the bar and the roller, and these are the little swirling things. Who thinks these names up? Was this a Stephen James O'Meara thing? M109. Alas, the Messier catalog ends not with a bang but a whimper. The last two objects, M109 and 110, are hardly lens-shattering sights. M109 is a typical barred spiral galaxy. Well, I don't think so. I think it looks like a vacuum cleaner. In fact, about 1/3 of all known spirals are of this nature, characterized by a prominent central vacuum cleaner bar. I added the vacuum cleaner. Of stars, off of which flow more delicate spiral arms. Well, he's kind of dissing it, isn't he? He says when he pans past this, he thinks he's found a comet, and then he sees the glow of the second magnitude FECDA star. Well-defined core and halo muddled with irregularities. Once he was observing it during an earthquake, and it brought out new detail. Did he really say that? He did. He says he has trouble making out the arms, but that's because he's observing live, even though he's Stephen James O'Meara. Wow, I think it's beautiful. With electronically-assisted astronomy, you don't have to be Stephen James O'Meara. Is by far the most distant object in the Messier catalog, followed by M91. Wow, is it really? How far? 38 million light years? Okay, we'll say that. Thank you, Stu. By far? He got all shook up, Elvis said that. He got all shook up. By far, the most distant Messier object, Stu. 38 million light years. Okay, 4 minutes, we're out of here. On to M102. Oh, 83 million. This is the Spindle Galaxy. For context, this is off of Draco in the northeast, between Boötes and Draco. We're going to just trust that we're aligned. And did we say this is M102? Yes. Oh boy, I just dropped my crackers. I hope they stay in the bag. You know what I better do is, I'm used to doing all this. This is all automatic usually. But I'm trying to save time and I'm not sure I am. Oh, the good news is the crackers stayed in the bag. The bad news is now I want to eat one. M102, its original discoverer, Pierre-Tech retracted his discovery 2 years later after publication and said that it was a duplicate observation of Messier 101. You know what? We actually correct this. The original 102 was, so what we go to now is an elliptical galaxy in Draco rather than the duplicate. Owen Gingrich has suggested this galaxy as a replacement for the non-existent M102 in Ursa Major. Therefore, it is presented as an alternate to be used by those wishing to find something for 102 rather than record the number when 101 is observed. According to Gingrich, which sounds like Newt a lot, Machine discovered and reported this galaxy to Messier, but the old ferret of comets never checked it, and therefore it was never added to the famous list. The galaxy is edge-on, with a prominent central bulge, giving it a lens shape. In larger telescopes, a dark lane is revealed in front of its bulge, 30 million light years away. So basically, this has nothing to do with Messier whatsoever, except a guy suggested it to him, and he never went and looked at it. That's just sad. I'm just going to mute myself so you can't hear me chewing on this cracker. I actually like it, but I've got a hot pixel there, don't I? And that's a new one, because I'm using darks and flats I just shot like one session ago. So I've got a brand new hot pixel. See that little blue deal? Brand new. This object was likely ignored by Messier, according to legend. Messier discovered it, but it appears Messier neglected to follow up on it. Cool central bulge. What's a hot pixel? It just means that one single one single detector unit out of millions. In my ASI ZWO ASI2600MC Pro, one single detector unit has essentially misfired. It's gone ballistic. It's broken, and it's a blue one, and it's always going to be on blue no matter what happens. So I shoot these darks. Oh, look, the darks aren't on. Well, that explains it. Okay, so let's take this picture. Well, I feel better because I thought, I don't want to like have a broken pixel up after just 2 sessions. Let's put these darks on. The one we want. So what we do is we shoot these calibration frames. The one we want is this one, shot on March 5th. Yeah, 10 days ago. And now, subsequent live stacks that we do, that frame will be ignored by the software. So it won't show up like that aberration again. In the meantime, I'm just going to go like this and save a real close-up of this picture without that hot pixel there. And that way I'll have an image of it without having to see that ugly hot pixel. This is M102, and it's 5 minutes, which is way too long on 2023 Messier Marathon. Can't believe we shot 5 minutes of something Messier didn't even see. This is a sad, sad night. Okay, here we go. We're going now to M63, a sunflower galaxy. M63. And wow, is it that close? No. So there's M63. It is kind of fun to watch the telescope training on it, isn't it? So for context, we're underneath the arm. Remember we were here for the whirlpool? Now we're about that much farther to get to M63. So we're off the east-northeast bearing of the observatory. Stu says a particularly attractive hot pixel. The group effort pays off again. That's right. Exactly. All right, so we should be settled. I'm trying to save time by not plate solving. Let's see if we get this. M63 here. Sunflower galaxy discovered by Messier in 1779 and observed by Messier shortly thereafter. M63 is a bright multiple-arm oval galaxy easily located near 20 Canem Venaticorum. It is oriented about 30 degrees from edge-on, which explains its oval appearance. Its multiple arms account for the sunflower designation. M63 is easily seen in small telescopes and binoculars. Large telescopes reveal some texture. About 35 million light years distant. Estimated diameter of 90,000 light years. Well, let's see here. We should have played solved. Oh, there it is. Boy, we had trouble with color balance, didn't we? It's a little bit odd color balance. Very odd, in fact. Let's do this manually. Let's bring this blue down to right there. Let's bring the reds down. But why do I have to do this manually, pray tell? Wow, it's really cool, isn't it? Look at the texture. After 80 seconds, it looks like a really serious washing machine. Wow. That's beautimous. 29 million light years. BOWKS1. BOWKS1, is that how I say that? BOWKS1. Welcome from Melbourne, Australia. Wish you had a clear sky there, but even if you did, it's the afternoon. It's a very busy galaxy, isn't it? Is that what you meant to do? It's a busy galaxy? I think it's still got too much red in it, doesn't it? That's a little better, isn't it? That's 2 minutes and 20 seconds. Warm, humid, and lots of high clouds. So 63, we're going to say, looked like a really heavy-duty washing machine. But sunflower galaxy is okay too. Bright core. Lots of detail. 90,000 light years, diameter 35 million. 90,000 light years wide, 35 million light years distant. It's beautiful. Thank you all for sticking with us. Don't forget to hit like if you like this kind of content. That helps make it fun because other people are more likely to see it in their searches. And also, if you don't mind, if you like it, we would love it if you subscribed. M94 is the next target. I'm going to Testing 1, 2, 3. I could try using the mic on the webcam, but I don't think it's going to be a very attractive sound. Can you guys hear now? The wireless mic I use, I've never done a live stream with it longer than 2 hours. It's completely discharged. So I wonder if I'm going to have to use the webcam for a while. Can you? Okay. Stu says yes, you can hear. I bet the audio is not very good. I do have some other microphones over there, but by the time I dug them out, I just think we'll be wasting a lot of time. So let's go with the webcam for right now, or I could use the microphone built into the computer. Let's try that and just see what it sounds like. Okay, so I'm going to switch mics again. Tell me which one you like. It's like in the eye doctor. Do you like A or H.264 USB camera microphone array? Testing 1, 2, 3. Okay, do you like this one better? Hello, hello, hello. Testing 1, 2, 3. Testing 1, 2, 3. Check. Testing 1, 2, 3. So do you like the one that was the webcam that I had a while ago, or do you like this one, which is right off the keyboard? The trouble is, I think there might be some typing noise sometimes with this one, and I don't like that idea. Stu says it's good. Was the webcam okay? Because that way we wouldn't get the typing noise. See, I bet you're hearing typing noise. Messier Marathon 2023, welcome. Okay, I'm going to try, point your mouth at it. I'm going to try switching back to the webcam. And the reason I'm going to do that is because it won't have the typing noise at least. Okay. Okay, so back on the webcam. Tappity tap. Yeah, okay. So I'm back on the webcam now, and we'll do this until this microphone is recharged. All right. Where were we? Quite obviously, we're here on M94. Wow, what an object, right? What do you make of this? Do you think this nebulosity is really there? Because that's incredible if it is. I don't think it is. I think that's a weirdness in my darks. Next time we'll try it without the darks. We'll try just SharpCap's built-in hot pixel correction. Anyway, that's M94, the Croc's Eye Galaxy. Let's go look at it here and see if there is. Oh, look. All this is there. That nebulosity is actually real. Boy, I just thought surely that's... But look how it has like a grain to it. Strange, don't you think? Okay, let's experiment with SharpCap's new built-in hot pixel correction only. Hot pixel removal only. Okay, back at a glob. So let's change this to M68 and slew to it fire opal. Okay, and for context, this is south-southeast, and it's right below Corvus, the Crow. We're at about, oh wow, are we really that? We're at 16 degrees. So we're getting lower and lower. That's a good sign. We're making progress here. I don't see a glob, do you? M94 only gets 11 degrees above the horizon from my location. Well, there you go. That's why they put it here now, because it's only 16 degrees above the horizon here. A 2009 study conducted by an international team of astrophysicists revealed that the outer ring of M94 is not a closed stellar ring, but a complex structure of spiral arms when viewed in mid, infrared, and ultraviolet. How about that? Ooh, I think I might see it in the middle. Oh my goodness, what a colorful airplane wing. Crazy. Okay, we're gonna have to use our imaginations here a little bit, but I think you're gonna be able to see it. I'm gonna lengthen this to maybe 7 seconds. Yeah, there you go. We're at 75%, so I think we're going to have to refocus in a while. Let's see what our temperature is. Yeah, 24 degrees we've dropped. We've dropped 3 degrees, and it was enough to throw off focus. So for this glob, what can we say? M68. Discovered by Messier in 1780, this globular reveals some details to scopes of 6 inch and above. Distance is estimated at 46,000 light years. Diameter is 100 light years. Larger telescopes resolve many of the globulars over 100,000 member stars. 100K stars. Uh, 46,000 light years. Okay, we're going to drop the camera for a second. Open up Nina. Grab the camera. It worked. Grab the focuser. Thank the Lord. It worked. And run out of focus. Jim Fox. Jim, you're up late. It's after midnight. Are you aware that you should have turned into a pumpkin? But it is nice that you stopped in. Jim, our microphone battery died. We're recharging it. The good news is it's already halfway recharged. So it must recharge fairly quickly. Is anybody else hungry? I'm hungry. Shouldn't we eat something during this refocus? What are you guys thinking? how about could do a granola bar, Cliff Bar I mean, or we could do half of a peanut butter and honey sandwich. While we're focusing, let's do half of a peanut butter and honey sandwich. I won't make you watch me eat, so I'm going to mute, and I bet our sound has stopped because we've run out of sound, haven't we? So we're going to go back over to here, yep, and reset. So I'm going to mute myself.
The spacecraft was a long way from home. I thought it might be a good idea just after Saturn
Okay, I'm coming back. Little by little, I'm coming back. Let's see. All right, did you notice, Stu, that while I was eating my peanut butter and honey, I was rejuvenated enough to realize the reason the scope cam was black was because it was dark out there. Imagine what a revolutionary thought. So I turned on the low light compensation, and now we have a scope cam again. What do you think of that? How about that? Okay. Meanwhile, back at the ranch, we just had finished M68, right? We did our observation of it, yeah. And now we're ready for M83 in Hyades or Hydra or something. Hydra. Let's see. So let's slew to it. And put M83 up here. Wow, M83 is just at 8 degrees above the horizon. I wonder if that's going to be visible. Eight degrees is very low. Well, look, it is. Hallelujah. Okay, so this is evidently the southern pinwheel galaxy. Oh my goodness, Stu gave a super chat of $5 for Doug's coffee fund. You're nice, Stu. You're wild. You're wild. Okay, so is this the galaxy right here? Should we play solve to be sure? Let's do it. We want to make sure we're looking at the right part of the sky. Hey, how about that? We got our scope cam back. Stu says, it's dark outside? No. Oh my goodness. Anyway, M83. Yeah, that was it. So now let's set Oh, I just love being able to see the telescope again. Oh! That should be good for another 3 hours now. That's right. Okay, first we're going to reset the display histogram and then reset the color. Okay. M83, known as the Southern Pinwheel Galaxy, is a barred spiral approximately 15 million light years away in the constellation borders of Hydra and Centaurus. It already looks okay at 60 seconds, doesn't it? I mean, respectable. I mean, you can tell it's a galaxy. Nicolas Louis Deluquier discovered M83 on February 23rd, 1752 at the Cape of Good Hope. Well, then he probably doesn't speak French. Maybe Spanish. Nicolas Louis Deluquier. I bet it's Portuguese. Okay, so we're going to do observation here. Can't see, stuck on slew cam. Thank you so much, Stu. You are a true friend. A true friend is one who says, you've got some egg on your face. Okay, so this is southern pinwheel, barred spiral, 15 million light years away. Discovered February 23rd, 1752. These people that discovered these galaxies way back then, I feel bad. I mean, how did they see this stuff? Attractive barred spiral. It's kind of wild how those arms. Man. What a mess that is. What is this, 83? Large galaxy. Amorphous. Hard to locate, he says. It wasn't that hard with our iOptron Sim 70G. You know, I hate to admit this, but in one presentation I heard on the Messier Marathon, the guy said, doing a Messier Marathon with a go-to scope is like running the Boston Marathon in a car. I tell you, with the temperature out there being right now 24.3 degrees, I am not going to stand out there all night long and stand beside the scope. I'm sorry. He basically says one of the 25 brightest galaxies in the heavens. That's cool, isn't it? One of the 25 brightest galaxies in the heavens. No light pollution back then. Probably, yeah, you're right, Stu, a lot less, huh? Sky must have been real clear. Sky must have been real clear. Kind of cheating, but awesome. Yeah, that's right. Condensation factor. Okay, so we're going to save this. 4 minutes and 40 seconds. Let's go back out to auto. All this stuff is automated in that, but I'm trying to save time by not plate solving. Let's go to 400. Let's go to M104. Oops, I forgot to stop plate solving. Below freezing, it's the icing up factor. On the person, I don't think our scope is having any trouble with it, but yeah, for me it would be below freezing. Look at this. Is this the galaxy right here, you think? Super edge on. Black dust laying there. That's a 3-second capture. 104. And we'll show chart. So for context, we're still around Corvus, but now we're above Corvus. And Virgo is right beside us. Oh, the sombrero. 104, of course. Look at that. Already visible, kind of. This has always looked a bit like a flying saucer to me. We can't see icicles hanging off the scope. Yeah, you're right. No icicles yet, but it is cold. 24 degrees out there. It's a faithful scope, isn't it? Just keeps churning away at 24 degrees. Wow. So back, meanwhile, at the Sombrero Galaxy, it's kind of cool, isn't it? Boy, can you imagine being the first one to discover this? You'd go inside your house and say, honey, you've got to come out and see this. Oh, Charles, you're always wanting me to come out and see another object. I've seen tons of those. But honey, this one is so cool. Look, I'm in bed. I'm not going to get out of bed. But it looks like a flying saucer, honey. Honey, it probably is a flying saucer. I mean, can you imagine discovering this? This is so cool. Well, there you go. 100 seconds to the Sombrero Galaxy. X-Files, right. We're going to save this and move on. 104. It's definitely X-Files Galaxy. Michael. It's 1/5 the size of the Milky Way, huh? So it's closer, right? $50 million light years? That's super far away. I thought that one object a while ago said it was the farthest. But it wasn't 50 million, it was like 39. Something's out of whack. Okay, stop live stacking. And off to M61. The farthest was 83 million. Okay, that's pretty far away. $83 million. Look, there's something here. I bet that's it. Think? Let's go back to auto, which means full screen. Yeah, I bet that's it. Okay, back to 20 seconds. And 100. And it's M61. And livestock. Well, it looks like we still have 7 on the live stream, and I just want to say for you 7 to be on here at 1 a.m. still Eastern, I think that's pretty amazing. Okay, not as amazing for anybody who happens to be on from Tauranga, New Zealand, because it's only 1 p.m. in the afternoon for you, right, Stu? But for you guys that are in Eastern time, this is really dedication for amateur astronomy. And keep in mind, tomorrow's probably a work day for you guys. You guys remember that, right? Don't you have to go sleep to be able to work tomorrow? M61. Excuse me. Wow, look at that. Very cool. So I'm going to use the shift key and fine tune the sky a little bit darker, and then bump up the mids a little more to brighten this baby up a little. Not quite that much because we don't want the sky to turn bright. Okay, M61. Discovered by Barnaba Oriani. Huh, 6 days before Messier. Messier had observed it on the same night, but same night as Oriani, but mistook it for a comet. Let's do. Oh, 6 p.m. Gotcha. Michael, you're in Eastern time. 45 million light years. Cubish, right. Wild angles. Kind of cubish. The cubish galaxy. Michael. Look at all this nebulosity out here. M61. Let's show chart and look here real quick. The swelling spiral. Huh. Oh yeah, look. There's the inner cube. When you get it right there, you can see the inner cube. Extremely interesting. And now we're starting to see those outlying arms. Barely. But they're there, look. Fascinating. Okay, that's M61. Next up, M49. Wild angles. 8 extragalactic supernovae have so far been discovered in M61 from 26 to 2022, making it one of the most prodigious galaxies for such cataclysmic events. I remember this. I think it was nicknamed the Fireworks Galaxy because it produced so many. M49 is next. Again, if you tuned in late, you might be wondering why this order. Because we're not going in the order of the objects in the Messier catalog. But that's because Messier didn't put them in any kind of logical order. He just must have put them in the order of discovery. And why are we not going anywhere? M49. Was that M49? Maybe that was M49. So now we got to go to M58. No? Oh. M61 was a fireworks galaxy, so we do have to go to M49. So why isn't it moving? Show chart. So now we're going to be within the arms of Virgo. And that's kind of a bulbous glob galaxy. There. Okay, so now it's in the center. 20 seconds at a gain of 100. M49 livestock. Giant elliptical galaxy about 56 million light years in the equatorial constellation of Virgo. Stu says, finally happened. Scopes frozen in place. That's great. This is the last image, remember. Remember the sharp cap still retains that last image. Now here's the new thing. M49. It really does just look like a blob. It is nearly round, 50,000 light years diameter. 42 million light years away. Stu saw that it was 56, and I trust yours more, Stu, because it's more recent. And the nucleus is emitting X-rays, so there must be a supermassive black hole with an estimated mass of 565 million times the mass of the sun. How much bigger the black hole's grown in the 56 million years since those X-rays reached us. It's terrifying. super massive black hole. 565 million times the mass of the sun. X-rays. Let's do M49, the blob galaxy. Can you imagine someday if this blob galaxy, if aliens come from there to invade us, they probably all will look like they're all round and rotund. But we won't make fun of them, will we? We'll be very kind. Right? Life is radiation. Oh, you guys are wild and crazy. 55. This is halfway home. It's M58. But it is the 55th object that we've observed tonight. M58. You know, this seems like a fitting time to post the chart of these objects in a place where you guys can see them, right? So you can see what's next. Wouldn't that be nice? M58. Export, or maybe save as. Save as, nope, that's not it. Export plan, custom. Export conversion type. How do you export it? I know there's a way to do this. What about down here? No. Backup. No. Print? That's crazy. I know there's a way. M58, the Ring Bearer Galaxy. Let's have a look. Hello. Boy, it looks small, if that's it. Angular size. 5 arc minutes. Yeah, it's definitely small. Compact form. 50,000 light years diameter, 42 million light years away. Oh, 68 million. $68 million light years away. The Ring Bearer galaxy. Intermediate barred spiral with a weak inner ring structure. Huh. I guess yeah, I guess this must be the inner ring. And that's it. Sure seems faint, doesn't it? Barely discernible dust trails. Next up is M59. And M60 should be in the same frame, same field of view. Depending on who's holding the tape measure. Stu. Plate solving here, since these are fairly close. I want to make sure we're observing accurately. We were spot on. Just that slight correction. Oh my goodness, look at all these galaxies. So there's M59 in the middle, and here's M60. And the rest of them are all non-Messier galaxies. Many of them don't even have NGC numbers. They have IC numbers. I think Stu was the one who said one day, that means once you've observed them, you say, I see. Okay, so 59 is in the middle. Corin Lewis, good morning. You're up a little bit early there. It's just 5:15 in London. IC is another catalog like NGC. I think I would be guessing, but I think it's, no, I better not say, because I would just be guessing. Astro catalog IC meaning. Index catalog. 5,286 galaxies, nebulae, star clusters discovered between 1888 and 1907. So this is M59. Fainter and smaller. $42 million light years distant, 24,000 light years wide. Well, Corin, we're glad you tuned in on your way to work. Faint, small, 42 million light years distant, 24,000 light years across. And on the same frame, where is it? Is it that? M58. I mean, that's M58. This is a cool galaxy. It's not on the Messier list, but it's called the butterfly galaxies. Isn't that cool? So this says that's M58. Can that be true? M89 and M58. That was here. Oh, we already observed that. M89 anyway is right here. Let's take a look at it while we're here. Maybe just needed to reset the lie stack. So that's M59, and this is M60. So kind of a twin there. 42 million. Mm-hmm. $42 million light years distant. This Virgo cluster is just filled. Look, everywhere you look, there are more galaxies. See? There's 59, and there's 60. And look at all these galaxies. Crazy rich in galaxies. All right, Markarian's chain. Now let's look and see where to frame this. So that's M84. We're also going to want to see M86. '84, '86. 87, 88. M84, M86, M87. That's not going to fit. M88. No. M86 is the one we should center on. Slew to it. The catalog of principal galaxies. PGC is an astronomical catalog published in 1989 that lists identifications for 73,197 galaxies. Corin says, I love to image that. Cool. All right, so this is going to be M86, I think we said. M84, 86, M84-86. M86 lies in the heart of the Virgo cluster of galaxies and forms the most conspicuous group with another large galaxy known as Messier 84. Yeah, right there they are, huh? Maybe? There they are. So look how you've got one here, one there, and then two here. So that's one here, one there, and two there. This is called the eyes, and it's an NGC object. So M84 and then M86 is the one in the middle. M84, M86, and the two NGC objects. And then these two are NGC 4402 and NGC 4425. Man, it's galaxy rich, isn't it? Virgo cluster is a large cluster of galaxies whose center is 53.8 million light years away. The constellation Virgo, comprising approximately 1,300 and maybe even 2,000 member galaxies. 2,000 galaxies, each with billions of stars, most of which have many planets. Run for your lives! Okay, so M86. M86, the middle of Markarian's chain. M84. First link in Markarian's chain. Virgo cluster has 1,300 and possibly 2,000 member galaxies. Curtis, I see you asking if I made a Discord channel. I just decided to hang out here on YouTube because it just was so easy for me to stream to YouTube and keep the audio here. So no, I did never do much on Discord. I mean, I got on and I think I maybe made an ID, you know, credential, but I just didn't figure out how to love it, Curtis. I'm so sorry. It's bad, isn't it? Well, here's this cool chain. See, 1, 2, and then 2 here and 2 there, and then 2 more here off screen. So if we go back out to full auto, you get 1, 2, and then 2 here, and then 2 down here, and then another tail off screen here. Chain is a good word for it. Yes, it's a cool chain, Corin. Okay, so we did 84 and 86. Now we're ready for 87, 88, 89. Let's look at those. So that's 87. Where is 88? Oh, it's going to be off. I think we might could get them both in. Maybe. You can also do center of screen. That's what we need to be doing. Center of screen. You don't have to find that star like I'm doing. but let's see what it looks like. So this is 87, and the spiral one is 88. '87, '88. Waiting for the 20-second exposure here. I don't know if we made it or not. There's that one. But where is this other one? What I'm doing in these cases is solving but not moving it since we have the live stack going. Let's see how our microphone is doing. It says it's completely recharged. Let's try it. So let's see, this goes here. And this plugs in here. Corin's watching this EAA live stream on the bus on his way to work. That's crazy, isn't it? Okay, so here's deep sky image annotation. So there's M87, a zillion galaxies, but I don't think we have M88. There's M87. These are all IGCs. Boy, look at this list of them. Nope. We missed it. Anyway, there's M87. Looks like an elliptical. Oh, look, there's a jet there. Can you see it? Let's look that up. M87, a blob. We noticed a jet streaming out of the top of it without being prompted. Can you see the jet? It looks like a thorn. Okay, so let's go out to M87. Look at this, guys. That's that jet. the Hubble view. Let's search for the word jet. It says a supergiant elliptical galaxy in the constellation Virgo that contains several trillion stars. Not million, not billion, trillion stars. One of the largest and most massive galaxies in the local universe. It has a large population of globular clusters, about 15,000 compared to 150 to 200 orbiting the Milky Way, and a jet of energetic plasma that originates at the core and extends 4,900 light years, traveling at a relativistic speed. It is one of the brightest radio sources in the sky and a popular target for both amateur and professional astronomers. And you saw it with the RASA. You saw it with an 11-inch RASA, and we're observing the jet without being prompted. Does anybody else think that's cool? I just think that's so cool. That jet is energetic plasma that originates at the core. It is energetic plasma originating at the core. That is 104.7. Has a greenish hue. Wow. And its relativistic speed is 4,900 light years. You know, that is kind of cool that you can see something even though it's that far away. It's distance. 1.6, no, 53 million light years. So what that means is even though it has several trillion stars and 15,000 globs and lies 53 million light years away, we could see that jet extending a mere 4,900 light years out from the galaxy. You know, to me, this was worth it. It's like a radio station, Michael says. Michael says it has a greenish hue. You might be right. I think you're right. But maybe that's just the way we have it. But the color balance says it's true. Well, that's exciting stuff. I'm so sorry we stayed 8 minutes on that, but it's really interesting to see that crazy geyser. Okay, so now we gotta find 88, which didn't make it in the same frame. So M88, we might as well just center on it now. Let's trust that it's there and just start light. I hope it was there. M88, bright elliptical, 42,060,000 wide. Bright elliptical, 42 million light years distant, 60,000 light years wide. There it is. Man, that's definitely cool, isn't it? You know, you just have to admire the grandeur of all of this. I mean, I don't know about you, but for me, it really does prompt me to believe in a creator, just because this stuff is so outlandish. I just have such a hard time thinking that this could have popped into being with no design. It's just, that's just inexplicably cool, isn't it? Look at that. It's like the most powerful hurricane-looking thing. Let's make us some time here, since we spent a little more time on the relativistic jet. And perfect, Michael says. Okay, so back to 3 seconds and 400 gain. Let's head toward M89, also in Virgo. And let's show it in the planetarium software. So there's M89 and there's M90. We'll be able to get both these in the same frame. You think it's there? M89 and M90. Gonna have to live stack for sure. M89 and 90. Temperature is 24.1. Okay, I've got this other mic working now. Let's see if we can go back to this while that's stacking a bit. So first, let's testing 1, 2, 3, test. Testing 1, 2, 3, test. Checking 1, 2, 3. It's turned all the way up. Testing 1, 2, 3. Testing 1, 2, 3. Boy, it's not as loud, is it? Can you guys hear that okay? Oh, the hiss is gone. Okay. Okay, I'll just remember to speak up a little bit. Oh, good, Stu. I'm glad. Yeah, that webcam mic is not that great, and it's probably picking up the little floor heater, I bet. But like I say, I just had to recharge this silly wireless mic. Now this was 89 here and 90 there. So that's 89. Looks like another blob, doesn't it? Resembles M87, yeah. It's smaller and fainter. Unremarkable in most aspects. 42,080,000. Resembles M87, but fainter. $42 million light years away, and 60,000, no, 80,000 light years wide. Good, Corin. Thanks. Stu said good night. Hope you have a good night, Stu. Thanks. Not as loud, but nicer. And then 90 is this one. Wow, that's got some cool structure to it, doesn't it? What is all that pattern on top? Looks like hieroglyphics, you know, writing or something. Look at that bright core. $42 million, also the same. Like M89, 42 million light years away, and 80,000 across. Oh, you're saying goodbye to good night to Michael. Features a structure of gas and dust extending 150,000 light years and jets of heated particles up to 2/3 of that, indicating there may have once been an active quasar on radio galaxy. Is that 89 or 90, Stu? I bet that's 89. No jets visible. Yeah, 89. All right. 91. M91. Cool. Good night, Michael. Thanks for being with us. M91 is the faintest object in the Messier catalog. "20 seconds. 400 or 100 gain. Huh. We're not removing pixels anymore. Now we are again. I don't know if you guys noticed, but I saw a hot pixel a while ago and I thought, something's gone awry there because it's not removing those hot pixels. M91's at 53 degrees above the horizon. Actually 63 now. Looks like we only have 5 more objects. And then we get that gap. The last one we have is M57, so let's see if this is M91. Let's count. 1, 2, 3, 4, 5, 6, 7. Sorry. 7 more after this, and then we have that gap. So that's when we can take, if you're in Eastern time zone and you need it, we could take a nap. So this must be M91. Looks like a barred spiral, maybe? Does that sound right, Stu? Does it seem like a barred spiral to you in your notes? Yep. Barred spiral, 63 million light years. 91, M91. Huh. It is faint, for sure. It would be hard to find, man. Can you imagine being out there if it's 23 degrees? Oh, 2 a.m. in the morning. I don't see how anybody could do it. Stand out there at 23 degrees and try to find that object, as tiny as that is. We're at 136% of the RASA's native view. So we're beyond optical and into the digital zoom. I don't think it would happen. I honestly don't. And then M98. It's beautiful. M91 is also classified as an anemic galaxy, a type of spiral galaxy characterized by a low contrast between its spiral arms and its disk. M98 is an intermediate spiral 44 million light years away. M98. Intermediate spiral, 44.4 million light years away. $80,000 light years across. Nearly edge on. Pretty amazing. Yes, we're on 98 right now. Pretty amazing. Next is 99, the Pinwheel Galaxy. I can see that, Curtis. It's just really easy on YouTube because you just start OBS and hit the start streaming, and you never have to connect anything else. So it's just pure running out of time to lash up other things, you know what I mean? But honestly, I mean, I don't mind that. I think Zoom gives you that audio as well. You know, if we wanted to do Zoom, we can use Zoom to stream. But I don't know. I just haven't used Discord for audio. I've sent messages through it as text messages, so to speak, but not for audio. Corin, you were asking what time it is here. It's 2:01 a.m. Eastern Time. Stu, thanks. M99 was one of the first galaxies in which a spiral pattern was seen. This pattern was first identified by Lord Rosse in the spring of 1846. Wow. You can see why he identified it, because they're so loose. The spirals are so wild. Flailing arms. Then M100. William Parsons, 3rd Earl of Rosse, who lived from June 17, 1800 to October 31st, 1867, was an Irish astronomer, naturalist, and engineer, president of the Royal Society. He built several giant telescopes. Very cool. Okay, looks like we're settled now on M100. This observing software is Deep Sky Planner, and I had used the Messier list in it before, but I have to admit that I've not had it yet for a year, so I hadn't actually scheduled the observing list for a Messier Marathon. So I did have to use what they call what Phyllis Lang calls the user integer field, which was empty, and I used it for the integers of the actual order that we needed to take in order to get the most objects done in the time we had. Because like I say, you can't do it in the order of the Messier numbers. So I use the integer column, and that's where I'm getting these. It's like the observing sequence order. And then like I might have told you earlier in the evening, I sent this to Phyllis in case she can publish it and let somebody else use it, so they don't have to type all those numbers in and get that all figured out. This is M100. Large, nearly circular spiral galaxy discovered by Messier in 1781. Stu's writing about this Earl of Rossi, who had a 72-inch telescope. The Leviathan of Parsonstown was the world's largest telescope at the time. 40,110,000 across. 100. Not quite face on. 42 million light years away. 110,000 light years across. It's pretty, isn't it? It has a bluish tinge, and I'm not doing that. That's something that's coming from inside of it. And that takes us to M13, which is the most famous globular cluster, right? Huge. It's the famous, some people just call it the Hercules cluster. Stu says M100 was discovered by Pierre Messier in 1781 and 29 days later seen again and entered by Charles Messier in his catalog. This Messier guy, I think he discovered more than Messier did. We should have called it the Messier list. Oh yeah, it's beautiful. Look how giant and absolutely stunning it is. Giant, stunning. One of the most spectacular sights in the Northern Hemisphere. It was added to Messier's original catalog in 1764. (21,000 light years away, 160 light years across, so it's very close. 21,000 light years away. 160 light years across. And M92. There's M92. Oh, that's bright, isn't it? M13 was discovered by Edmund Halley in 1714 and cataloged by Charles Messier on June 1st, 1764 into his list of objects not to mistake for comets. M92 seemed super bright on our screens. Yeah, he calls M92 truly spectacular, deserves more attention. It would get it if it were in any other constellation, but because it's pitted with M13, M13 always wins. 35,000 light years distant. 88. So 35,000, 88. M92. $35,000 light years distant, and 88 light years diameter. Stu says discovered by Bode on December 27th. 1777. Pretty cool. And M56. M56. Boy, is that as low as I think it is? Yeah, that's just 5 degrees above the horizon. I wonder if we'll be able to do that. Look, you can see we're looking through the trees. Oh, those are power wires. M56. And it's supposed to be a glob, and I'm not seeing it. That's fascinating. Let's see where those power wires are. Show chart. So that's east, northeast. Yeah, I know right where those are. That's fascinating. I don't know if this is it, but it's supposed to be a globular. 32,900 light years away, measures 84 light years across, containing 230,000 solar masses. Was a half degree off, so it's quite a shift. Waiting for it to make its correction. I guess it already did. So let's do the deep sky image annotation. Oh, it's very dim there. Of course, it's behind those power lines too, but oh yeah, there it is. Let's increase this to maybe 8 seconds. Yeah, there it is. Nowhere nearly as bright as M13, huh? yet still packed, and 32,900 light years from Earth, 84 light years across, 230,000 solar masses. Stu. Thanks, Stu. Oh, part of Gaia sausage? The hypothesized remains of a merged dwarf galaxy. Now we're out of the power lines. Was at first in power lines at, what were we? Five degrees above the horizon, yet still visible. Okay. Oops, that's M56. And I think the last one we'll be able to do is the Ring Nebula. M57. And what I mean by last one is the last one before this big gap. Because all the other objects, well, there are a couple down there that might be high enough. No. They're all below the horizon except maybe one or two. We'll look at it. Look at the Ring Nebula. Wow. And that's without stacking. Yeah, Gaia Sausage. That is a funny name, Stu. Look at this Ring Nebula view. You can see if you look very closely at just 8 seconds, you can see the central star. Again, this is a planetary nebula that's shed off that outer layer. And you see how at the poles, it's got that reddish hue again. You can see color at the poles, even at 8 seconds, single exposures, 400 gain. This would be a lot more beautiful if we took time to stack it, and we should do that on another night. Let's try to jump to this M5. I'm not sure why it's down there several lines, but let's try it. M57 is 2,570 light years from Earth. Stu says. Thank you, Stu. Yeah, there it is. It's M5 right here. Ooh, that's sharp, isn't it? Wow. M5. Look how beautiful that is. Stu says, discovered by Gottfried Kirch in 1702. constellation Serpens. It was tack sharp with 100 plus members visible in real time, 8-second shots. I don't know if we'll be able to see M10 or not. It's just at 10 degrees above the horizon right now. 11 degrees above the horizon. Yeah. There it is. Pretty amazing. At just 8-second exposures. M10 was remarkably clear, even though it was only 10 degrees above the horizon. Let's get an idea of where that is in context. So here's the tree line. I guess that's just a very low horizon there, and that helped us. See, if it had been over here, it would still been in those trees. So we should also be able to do M12. And that will be it. This will be our final object that we can do on this side of the gap. And there's M12. Spectacular, globular, $20,000 light years. 20,000 light years distant. But the interesting thing is its diameter is 80,000 light years. So it's huge. Being so close. Okay, how do you want to do the broadcast? I mean, I kind of wish we could leave it run. I could just put on music and go to an object and let it be imaging it. And I think what I'm going to do is try to grab some sleep. Let's get an idea of when these will be up. They look like, okay, leave it stacking on the Ring Nebula, will do. They look like they're all going to be in the neighborhood of let me get a prediction here. This patch here, like M54, is representative of kind of the middle of them. M54. So why don't we go over here and search for M54 and then run the clock forward. So what we're doing is we're watching M54 rise. And now, so let's find it again, M54. Oh, it's right here apparently, yeah. So there it has an altitude of 9 degrees. I doubt if that's going to be a problem. And that is at that's at 610. So why don't we start back around, let's see, it's 2:30. Let's start at 4:30. I'll try to be back at 4:30. Yeah, that's right, Stu. It's 2:27 now, Corin. And so, yeah, 2 hours from now, 4:30. We'll take a 2-hour nap. And I'll go to the Ring Nebula and just let it be, you know, stacking frames. Two-hour nap. Yeah. Hey, thank you all for being a part of this. We're so grateful. It makes it so much more fun. This would be a lonely job without you. So really appreciate it. I'm going to put it on Ring Nebula, let it stack, take a 2-hour nap, be back at 4:30. Hope to see you then. And I mean, I hope you can come back, but I understand if you can't. I know you got to sleep some because it's probably a work day tomorrow for you. So we'll do our best. But on my end, we'll be back at 4:30. Thanks a bunch. God bless you guys. Hope to see you then. Thanks, Stu. Okay, I'm going to put this on mute. Well, let's see. Is our audio back going again? Because we better get going, huh? Get on our horses and go. Let's close our camera in SharpCap here. And well, it's kind of like on some kind of delay. Here we go. I suppose it wouldn't hurt to close the whole program and let's open up Nina. And do a quick focus. We're down to 20 degrees temperature now. Let's let that autofocus. Maybe I'll eat some peanut butter and honey sandwich while that's while that's autofocusing here. So I'll just mute the mic while I eat. Okay, let's check our pre-processing. Put that back on hot pixel removal. Let's make sure it's the right flat, which it was not. All right, we're back here in business. I'm just quickly breezing through the let's run this again. There we go. Looks like we did not go to this globular cluster. So let's try to go to that. See, slew to this. Just at 17 degrees. Yeah, right there it is. This is M71. So we'll just say see, where are we here? The 72nd object. M71. 12,000 light years distant and 29 light years diameter. One of the most beautiful clusters when viewed at a moderate magnification because it's immersed in a rich Milky Way background. Yeah. Rich background and 12,000 light years distant. And 29 light years diameter. Oh, there you go, Stu. Well done. You're back at it. Thank you, Stu, for being here. Discovered by Cheseau, I guess, in 1745. Good. Not particularly packed, but still noteworthy. Did we do this? I don't think we did. This is the M27, the Apple Core. The Apple Core Nebula, M27. Well, I had a good little nap. I don't know if you had a chance to rest, but we're glad you're back, Stu, and we've got probably still 5 of us on here, I guess. Oh, thanks. Appreciate it. There we go. Let's go to 10, or actually 20 seconds, and make this 100. And let's put the target name here, M27. go. So let's auto stretch this and do a new. We have had the moon rise since getting up, and the moon's not actually, it's about 50-some% illuminated, 57%, something like that. That's a pretty striking planetary, isn't it? That's very visible. The red here, the hydrogen in the poles, and you can see the, I don't know if that's the central star. It looks like it is. This is one of those planetary nebulae that the Dumbbell Nebula, also known as the Apple Core Nebula, Messier 27, is a planetary nebula in the constellation Vulpecula at a distance of 1,360 light years. Yes, I like the Ring Nebula too, but the scope had gotten out of focus during those 2 hours, and I regretted that. So in a real astrophotography setting, obviously, we would have refocused during those 2 hours. But seeing as how we were out of it, I did sleep. I went right to sleep. Wow, look at those reds. This is such a large planetary nebula compared to the things we've been looking at in the Herschel 400 or the Caldwell list. This is so huge, isn't it? Even after 2 minutes, I think that's just remarkable sight. It's like you look at that and you think, is that really up there all the time? Well, it is. Next target cycle. I wonder if this would take care of some of those settings for us. Yeah. And then what we'll do is we'll stay let's stay in the 3-second zone at 400, and let's go to this open cluster M29. Guess we better say something about the Dumbbell Nebula Apple Core is 1,360 light years away. Stu looked striking. Or like Schrodinger's cat, was it really there before being observed? Like the tree in the forest that falls down, you're saying. Can anybody hear it if it falls down? Flatwater 5! What do you mean? You got to be kidding me. What's up? Oh, it's good to see you, Flatwater 5. What are you doing up this hour? Pray tell. I think this is all there is to this cluster. Let's plate solve to be sure, but who is up at this hour? That's the question. Oh, I need to change our title. Say Messier Marathon 2023 live via RASA 11-inch. Now this should let us do a yeah, M29 right there. So this is pretty sparse, actually. I wonder how many members this has. 74. Sparse and coarse. 12 members. often overlooked. 6011. So sparse. Course. A dozen members. 6,000 light years away. 11 light years wide diameter. Good to see you, Flatwater 5. Can't believe you just get home from work. And slew to M39. Wow, look how open this is. Very, very sparse. M39, 1,000 solar masses, 3,000 light years away. Flatwater 5, the most intelligent programming I've ever seen at this hour. I don't know, Flatwater 5, if that really means that much compared to what's on at this hour. Most of them are infomercials, aren't they? And we're not really trying to sell anything here. Yeah, there you go, M39. Incredibly loosely packed. "30 stars. You can't even tell it as a grouping. Hard to recognize it. Um, 800 light years, 7 diameter. So we'll say seemingly even more coarse than M29. 30 members though. 24 members. I bet you're right, because you sure can't see much there. 800 light years distant and 7 light years diameter. And that takes us to M5. So we're on the home stretch. I don't know if you can see this fine print here. This is what we have remaining. We're on object number 776. And we're trying to get to 110. Like I say, we will not be able to get M30 110 just because of the nature of things. Of the 15 brightest components, 6 form binary star systems, 1 more suspected. It was this or Larry King's. What in the world? Okay, so we've got M5 globular cluster. Wow, look at this beauty. That's like a snowball, huh? I would say it's made even more striking by the dark background. Not a difficult choice. Messier discovered it in 1764. One of the 3 great show objects of the summer sky. Burnham called it one of the 3 great show objects of the summer sky. And 27,000 by 100. 27,000 light years away, 100 light years diameter. They talk about this star. Find double star. You can see the double component. Oh, your info says it was discovered by Kirch. Nothing about that in this Pennington book. How about that? Must have been discovered later after the Pennington book was done. All right, and then we've got M10. Skating into view. There's just something special about these globular clusters that have all the different colors of stars. Lots of greens and yellows. Rich cluster, 15,000 by 70. Rich cluster, 15,000 light years distant, 70 light years diameter. M10. Whoop. Wrong name. M10. And that takes us to M12, also globular, the gumball cluster, nicknamed. Well, I had a half of a, is that it? Right there? That's what we were just looking at, wasn't it? M12. Must be it. Yes, although around 2 of those hours were during the gap when there were no objects visible. So actually coming up on 9 hours, Flatwater 5. Yeah, there's M12. That's a pretty loose globular, isn't it? For a globular cluster, that's... Yeah, that's exactly what Pennington says, fairly loose. 20,000 by 80. Really loose globular, 20,000 light years distant. 80 light years diameter. The gap, that part of the night sky and the Messier Marathon when you've done the objects from nightfall and there aren't objects yet to be able to do for the morning side of things, kind of a gap. M107 is the next. M12, Stu says, is about 16,400 light years away from Earth and has a spatial diameter of 75. Is that what we said? 16.4 by 75. Let's check that. 16.4 by 75. I don't think that's what we said from the Pennington book. 16.4, 16,400 light years distant by 75. Yeah, we had said 80 from the Pennington book, but it's, like I say, it's got some age on it. So next is 107. I guess we're talking about up here. Boy, that's just really got that faraway look, doesn't it? Fairly large but faint. Not one of the more impressive globulars. Large but faint. $19,000 distant by 40 diameter. And a nice patina. And next would be M9. We're doing all these at 3 seconds, 3-second exposures. Gain is set at 400. So no live stacking needed on these. Here's M9. Quite small but bright, this globular appears to be a star in an 8x50 finder scope. It is a fuzzball in small telescopes, discovered by Messier in May of his marathon year of 1764, partially resolved in larger telescopes, distance of 19,050 light years wide. So 19K by 50, 19 light years distant, 50 light years diameter. So that's 107. Oh, and then William Herschel rediscovered it 9 years later, or 11 years later. M14. Boy, we're already back down to after this. It's pretty lower altitudes again. This is M14. Again, fairly faint and not large because there's 100% of our frame. This is M14. Remarkable for its even distribution of light. That's true. Pennington pointed out that it's remarkable for the even distribution of light. 33,000 by 112. 33,000 light years away. 112 light years diameter. Okay, an open cluster, M11. We're at 14 degrees now. Let's get a sense of where this is, just for context. the Wild Duck Cluster. See how we're kind of sneaking down on the eastern horizon again. Look at the rich Milky Way behind this. The Wild Duck Cluster. So this is southeast. So it's east-southeast near Aquila. Pretty striking, isn't it? Lots of orange and yellow stars and whites kind of stand out in the sky. Beautiful. M11. Strikingly beautiful. But why a wild duck? Why do we call it Wild Duck Cluster? Kirch discovered this in 1681, Stu said. Now we're at M26, another open cluster. M26. Looking over the east-southeast horizon now, just 13 degrees up. So I guess it's this. Let's go ahead and do a plate solve and a sync and get those back in the center of the frame. The Wild Duck Cluster is one of the richest and most compact of the known open clusters, one of the most massive open clusters, and it has been extensively studied. Let's see what time the sun rises here. Looks like sunrise is 6:23. 6:23 Eastern. So about an hour and 18 minutes. There, now we have this in the center. This is M26. Not a particularly striking cluster, is it? Not that striking, actually. Sparse, even. Oh, look what Pennington wrote. Not very impressive, and its Milky Way background makes it appear even less so. 5,200 by 21. 25 members. 5,200 light years distant, 21 light years wide. 25 members. Go to M16. Stu says, phew, fingers are blurring here. Can hardly keep up with you, Doug. You're sprinting the marathon. Yeah, I guess I'm feeling we still have, we're on 84 and we have to get to 109. Quite a sprint left. This is kind of similar, kind of open. This is M16, eagle shape. Too faint to be seen in anything but large telescopes. 17 inches and up. Well, I don't know about 17 inches, but we can see this. Some nebulosity can be detected. poorly concentrated coarse 6500 by 70. (6,500 light years distant, 70 light years diameter). Discovered by Chissot in 1745. Now we've got the Checkmark Nebula. That was the Eagle Nebula, along with the open cluster. Boy, you're right. We're just barely making out nebulosity there. But we saw the open cluster for sure. But yeah, to see that nebulosity, let's just do this real quick. 20 seconds, 100, and it's M16. Oh yeah, you're right. It's M16. The pillars of creation are in this. We can't leave without seeing some of that nebulosity. Even though this is a marathon, we have to. There you go. Wow. Just think, we almost missed that. And look, the pillars. After 20 seconds. My question is, who really needs Hubble? Okay, I'm just joking. You can see why they call it Eagle. Look, here's a wing, and here's another wing, and there's the head. To see those pillars well, we have to be at about 150% of the sensor of the RASA 11. But look what we would have missed, the difference between visual and EAA. The first view was what you see in a visual scope, and then look at what you can catch in a 11-inch RASA Hubble. No, it's no Hubble, but it's sure fun to see this, isn't it? That's just 80 seconds. Stu says JWST did it better. Excuse me. Look at all this over here too. Lots of soot and dust blocking that light, so it's actually shielding us from seeing the hydrogen lit up. Just try to get context of where this is. It's just 14 degrees up, and no astrophotographer would try to look at this when it's just 14 degrees above the horizon. You know, astrophotographers will wait till it's at least 20 degrees up, if not more so. And again, it's a great commercial for a RASA, isn't it? A RASA 11-inch. It's a fantastic commercial. That's 2 minutes and 40 seconds. We'll go ahead and save this. M16. Stu says yes, but we must move on. He's right. Okay, here we go. Let's end this live stack and put this back on. What were we on a while ago? That was working pretty well. 3 seconds at a gain of 400. And next is the Checkmark Nebula M17. 12 degrees above the horizon. Again, we're getting close to that tree line. This is the alleged tree line, and here's where we are. So we're very close. But look at this Milky Way. And sure enough, oh wow, this is great. M17. And we'll go 20 seconds and 100 gain. Pretty fascinating that this stuff is up there all the time, isn't it? It almost just doesn't make sense that they're up there like Easter eggs in the sky. Who would have imagined? Look at that. Is that not striking or what? The Checkmark Nebula. You know, we've never observed this according to this record. How is that possible? Wow, striking. Unmistakable. Comet-like streak with a hook at one end. Swan Nebula, Horseshoe Nebula, Chipmunk Nebula, 6,870 light years across. 6,800 light years distant. And 70 light years wide. The Omega Nebula, or Swan, Checkmark, Lobster, Horseshoe. Whatever you want to call it, it sure is beautiful. Wonder if we should do something with those greens. Let's bring those greens down. Yeah, there we go. A little better, huh? You know, if this were the only object that we saw all night, it would make a memory. Look at that. And it's so big. This is 85% of the RASA's field of view. Okay, so just to, this is at 12 degrees. Right above the tree line. Jaw-dropping, Flatwater 5 says. This, the Eagle, and Sharpless 254. Wow, look at that. That almost makes it look better to have all that rich star field. And then this nebula just wafting out like one of those, we've referred to it before in Star Trek, huh? Those ships that can just appear. What are those called again? I always forget. Very humbling, Flatwater 5 says. M17. Wow. I'll never forget this. But, as Stu says, we have to move on. Let's go back to our 3 seconds at a gain of 400 and head to the M18. Again, just 12 degrees above. Well, now it's crept up 18 degrees. M18. Boy, not much there, is there? Look, this is it. We're gonna just turn that off for a second and do a solve only to make sure that this is it. I want to make sure we're looking at the right part of the sky so we can truly appreciate this. Stu says, boo, boring. Klingon, that's right, Flywater 5. Is it Klingon? What was the type of ship, though? Klingon. Klingon. Isn't it named after a bird or something? Bird of prey? Yep, that's it. M18 right there in the middle. Boy, you know, I would never, ever have called that a cluster. I just wouldn't have. I'm not ever going to give info on this. Bird of prey. We would possibly never have recognized this as a cluster. Light and small, minor object. A dozen stars. Light and small, minor. A dozen stars. Let's go to M6. At 10 degrees, oops, I think we're into, no, we're going to barely make it. But we're very close to the tree line, I think. M6. Let's show the chart on this. Huh. It's odd, isn't it? It shows the tree line here, but there's something going on there. Maybe moonlight? Could be moonlight. Anyway, we are seeing the cluster here. This has at least got more members. Oh, nebulosity. Just looks like something's going on there. Let's go back out to our chart again. This is M6. Oh yeah, there's the moon. That's what's going on. The moon's just, where's that little... The moon's just 4 degrees away from it. I told, remember I told the lady who programmed Deep Sky Planner, can she give us a warning when this is happening? But see all that moonlight we're seeing. Let's reset this display histogram. Boy, it is reset. And then reset this. And then color balance that. Move this out of the way. I don't even know where to put this stuff. To get rid of that moonlight? I don't think we're going to get much nebulosity, do you? Too much moonlight. But we can see the cluster. Just not a lot of nebulosity. the moon was just 4 degrees away from this cluster. Butterfly cluster. Huh. Hodierna. Ptolemy. I saw you standing. Blue moon. Flatwater 5 is serenading us. All right, let's move on. 3 seconds. You know, that's why we need to go this coming Saturday, because there's no moon at all. But it's just going to be cloudy. So that was M6. So now we're on M7. This is even called Ptolemy's cluster. Mariposa. This is just 7 degrees above horizon. I don't know if we'll be able to see this at all. Will we? Is that it? Surely not. M7, 7 degrees up. So here's where the tree line's supposed to be. But look at all this bank of Milky Way nebulosity here. Known since antiquity. It was first recorded by 2nd century Greek-Roman astronomer Ptolemy, who described it as a nebula in 130 AD. Well, he was ahead of his time, for sure. Yep, that's it. It's big. We're out at full APS-C. There is luminosity here, isn't there? A nebulosity here. Ptolemy's cluster. It's right next to the last one and next to the moon. Recorded by Ptolemy. Close to the stinger of Scorpius. Flatwater 5 drinking his coffee. Here's Sagittarius, and there's the stinger of Scorpius. Spectacular. Let's go to this globular, M19. It's a little better, 19 degrees it says. In fact, I bet it's up a little farther now. Yeah, 20 degrees now. There it is. It's pretty compact, isn't it? M19. Of course, we were spoiled by those giant sky clusters. Bright, oblate, hazy spot in binoculars, 20 to 30,000 light years, 100 light years diameter. 19. 100 light years distant. Pretty wild. Amazing part of the sky, Stu says. 80 stars, 1.3 degree across, 980 light years. This corresponds to an actual diameter of 25 light years. Okay. The flickering globular, M62. What makes a globular flickering? Is that it? Yeah. I don't know about flickering. 11.9 billion years old. Getting on a bit. There goes an airplane maybe? Moving too fast, right? Flickering glob. 11.9 billion years old. Crazy old. Getting on a bit. Stu. It's a beauty. That bright core. How about M4? 23 degrees up. So we're up in the top of Scorpius now. Oh, look. Look at this nebulosity here around Antares. Crab globular cluster. Boy, that looks beautiful there, doesn't it? It's called the Antares Nebula. It's a nice cluster. M4. Seems like there's a famous highway around London called the M4. Loose but brilliant. 6,500 by 52. Loose but brilliant. 6,500 light years distant. 52 light years diameter. Flatwater 5 says, Holy Mary, that's breathtaking. That's awesome that you're... M5. Oh, no, I think this is M4. Oh, is the M5 the one around London? M4 was discovered by Chasseau in 1745, cataloged by Messier in 64. It was the first globular cluster in which individual stars were resolved. Oh, that's pretty cool. M80, one of the easiest globs to find, being 1.3 degrees west of bright star Antares. M80, that sounds like a firecracker, doesn't it? Look at that. These are all unique, aren't they, these globulars? They each have a different shape. Photographs by the Hubble in '95 found white dwarf stars in M4. They're among the oldest known stars in our galaxy. 13 billion years. That was M4. Small but fairly bright. Evidently discovered by Messier and Machine simultaneously, if such a thing is possible. 28,072, very condensed, easily seen. 28,072. 28,000 light years distant. 72 light years wide. Discovered in the same month by both Messier and, how do you spell Machine? So that's M80. And now let's go to the Lagoon Nebula, M8. Looks like we're close to the moon again, you think? Or is this just nebulosity? M8. Yeah, we're close to the moon again. Once again, it's 4 degrees. That's too close to do anything, to see anything. 4 degrees. What I told that lady is within 20 degrees, it's almost impossible. Marco, good to have you here. Slovenia. Wow, Marco, that's great. Slovenia. You know, your country has really advanced over the last 30 years, hasn't it? Congratulations to you. We are so glad you're here. Marko Snidar. Marko Snidar. This is M8. Diffuse Nebula, the Lagoon Nebula. I wonder if I need to clear this. It should have cleared it automatically though. Okay, so M8, all that moonlight, but look, we're kind of seeing at least a little bit of it. Let's see if we can tune it a little better. Reset that, reset this, reset those. What a mess, color-wise. My goodness. What do we have to do to this? Bring the reds down, I guess. And then bring the blues down. There we go. What an odd color matching in the live stack though. I guess the important thing is we are seeing the Lagoon Nebula even though the moon is 4 crazy degrees away from it. I don't know what effect it has if we try to darken the sky. Get rid of that moonlight. There we go, look at that. So basically we're telling SharpCap, ignore the moon. Pretend like the moonlight's not there. Wow. If this doesn't hook you on EAA, what would? Visually, if you looked at this with an eyepiece, I think this would just be completely flooded. See the lagoon? Wow. That's actually beautiful, isn't it? Even though the moon is ruining it for us. Flatwater 5, you're very kind. Calling that magnificent. Oh man, that is stunning. Those are beautiful words. But all this moonlight is just crazy. M8. Okay, we're out of here. Let's go to the Trifid Nebula. 17 degrees up. And this is still just 5 degrees from the moon. Yeah, 5.5 degrees. The moon's at 50, well, maybe 45% now. This is, Trifid is M20. I think we're ready to live stack here if we're in the right place. Are we? Boy, you would never know it's there, would you? It's just like the Klingon bird of prey that hasn't uncloaked. Or hasn't uncloaked. You can't see it anywhere in that image. Okay, so we're 40 minutes from sunrise. So that's going to be a factor soon as well. Yeah, we're on the right frame. So let's live stack. Were we not finished? We better reset that live stack again. We must have not been finished with our plate solve and sync. Here we go. Okay, so we'll reset this display histogram and then reset that histogram. Oh, there it is. Boy, you would have never known it's there, would you? Wow. That's 2 frames. Look at all this nebulosity. The Trifid Nebula, M20. That's an entire bank of nebulosity here. SH228. So this part is SH228. I've never even noticed before because I've been focused on the Trifid Nebula. M20 was discovered by Charles Messier June 5th, 1764. Its name means three-lobe. The object is an unusual combination of an open cluster of stars, an emission nebula, and a reflection nebula. Looks like a chicken foot. A chicken foot. Yeah, here's the, what? Is that the reflection nebula from that star and some nebulosity here? And then this is the emission nebula, the hydrogen there. And then this black is that dark matter, dark nebula, and then the cluster is behind it, illuminating the hydrogen. Pretty striking stuff. Emission cluster, reflection, all in one. Which columns do you sort in DPS to determine the order the list is best viewed on a given night? For example, today. Marco, that's a great question. Normally, when we're just observing for the sake of observing, we would have used the altitude and looked for the highest altitude. But in a Messier Marathon, it's special because you want to catch these objects before they set. Sometimes you have to catch them just as they're rising. So with a Messier Marathon, you follow an order that has been set by prior marathons to work out your best timing. And so what we did in Deep Sky Planner is we used Deep Sky Planner's user integer column, which normally is empty, just for this kind of a purpose. Phyllis leaves it empty for us for just this ideal kind of scenario. And we made a sequence based on Harvard Pennington's book, Messier Marathon Field Guide. And from his sequence, we put the numbers in so we could track them through all night. So this is sequence number 95, but it's open cluster M21. Blue is reflection, red is emission. Yeah. So this is M21, small and coarse, fairly compact, 5200 by 20. Small, coarse, compact, 5200 light years distant, 20 light years diameter. All right, that was M21. Now let's go to M23. We're at 21 degrees above the horizon. Excuse me. For context, here's where we are. Still kind of floating in that eastern sky. That's a nice cluster, isn't it? This is the full APS-C frame of the ZWO ASI2600MC Pro through this 11-inch RASA. And look, it takes up a large part of the 2-degree field of view. It's a huge cluster. Yes, it's very cheap compared to O'Meara's. Marco, that's kind of you to say thanks, but it's an honor to have you here, man. So M23, M23 is the steam rising out of the spout of the teapot. So here's M23, and here's the Sagittarius teapot shape, and the steam is rising up. That's kind of cool. The steam from the teapot. Large cluster. (2,000 light years distant, 15 light years across. But the thing is, its angular size seems big to me. About half a degree wide in the sky. Here's a multi-star system. That sounds like it's going to be another one of those. This is M24. 169 to 414 members of M23. M24, it's not actually an open cluster. It's a detached portion of the Milky Way, a star cloud midway between M8 and M17. So it's a 12,000 years, 20 light years wide. Man, what is it? Is it this? I'm going to do a quick solving of the frame here so we can, although we don't have much time, it's less than a half an hour till sunrise now. Yeah. Oh no, it's here. M24. See, we would have never caught that. We would have confused it with that open cluster, I bet. So it's just this star cloud here. That's kind of crazy, isn't it? I mean, with deep respect, why is that? A star cloud, not even a cluster, multi-star system, M24, not actually a deep sky object, not actually a deep sky object, a multi-star system. Wild. Okay, M25. At 16 degrees, let's make sure we refresh. 19 degrees now. M25. Oh, we got a show chart on this. There it is. Still hanging around Sagittarius. Oh yeah, that looks like a real cluster, at least. $50 members, 3,200 by 30. 50 members, 3,200, 30 light years diameter. And M22, also in Sagittarius, we're at 15 degrees with it. There we go. There's the glob, M22. The largest and brightest Messier globular cluster, but because of its low altitude, we don't really look at it as much as M13. But this is the largest and brightest, 9,600 by 70. Largest and brightest glob, 9,600 distant, 70 diameter. M28 is next. Wow, there you go. It's kind of amazing, isn't it? These big masses of stars bound together, kind of gliding around the universe together. Gliding around the Milky Way, in fact. M28. $19,000 distant, 65 diameter. 19,000 light years distant, 65 light years diameter. Yeah, there you go. Stu was talking about the brightness of M22, the last one. Let's head on over to M54. It's at just 7 degrees. Let me refresh this and make sure that's right. Ooh, that's going to be tough. M54 at 7 degrees. Can we see that? Look how low that is to the building. But there it is. M54. What do you got on M54, Stu? Very small, a fuzzball. Fuzzy star, 50K light years, 188. Very small, a fuzzball. 50K light years distant. And 188 light years wide. M69. Oh, M54 has a black hole. That's cool. 2009. Imagine if a planet would circle around a star in that globular cluster. If you could visit that planet, how bright would the sky look with all those stars in the cluster? Amazing. You're right, Marco. This is M69. It's another small one, isn't it? This is a very small glob. Small and tiny, 36,070. Very small, tiny, 36K distant, 70 light years wide. M69. Off to M70. M70 is at 7.9. Let me refresh that. 8.2 now. 8.2 degrees above the horizon. Which means it's right on our rooftop of this building I'm in. But right there it is. Wow, that is so small. Look how you lose it. It's just a fuzzy star. Another very small fuzzball-like glob. Fainter. 34K by 80. Another fuzzball. 34K by 80. 34K distant. 80 light years wide. That was M70. The same night he discovered M70, at the same time he was searching for an object in 1751. Okay, off to M55. Oh my goodness, that's 1.8. We'll never see that. Show chart. Okay, so that's behind the building right now. Sadly, it's even worse than it looks because this is likely the real line of the building. And this, remember, photographic image, I've got it a little bit lower so we can see what's coming up over the horizon for just this kind of a time. So we're going to have to come back to this one. Let's make a note of this, M55. I should write these down because obviously I shouldn't write it on that. Let me find something else to write it on. M55, we missed. Let's go to M75. It's at 4 point. Let's go to M15. So we're going to miss M75 so far. M55 and M75. Let's try this M15 glob. That we might get. Might be right above the tree line. Yep. Low declination in Paris meant there rises daily, very little above the horizon, so don't feel bad. He couldn't see it either. That's awesome, Stu. You're trying to cheer me up here. This is beautiful, though. Look at that one. Bright and beautiful. M15. Yeah. Easily seen. 34K, 130. 34 light years distant, 130 light years wide. I like this one. This one looks like a real thing. Maraldi. Tarzan 11. Okay, what else we got here? So we were okay until we got to M55 and M75. So we need those two, M55 and M75. And then I don't think we're going to get M2 yet. M15 is one of the most densely packed globular clusters in the Milky Way galaxy because it's just at 2.7. And M72 is just at 3.1. This is degrees above the horizon. And here's a multi-star system again, M73. It's just at 2 degrees above the horizon. And then the worst of all that I'm pretty sure we won't get is M30. It's still 12 degrees below the horizon. So starting here with 55, 75, 2, 72, 73, and 30. So we're already at 104, 104 objects. Let's just start looking at these. 55. we're just 15 minutes from sunrise. Are you feeling it? M73 is just 4 stars, worth a miss. Yeah, but it's one of these targets. I have to check it off the box. Okay, let's go ahead and slew to M75. And then let's show it on the chart and see how bad the news is. Well, now look, that's going to rise. But man, look, it's got to get above that tree. That just makes things worse for us, sadly. Now let's look at the real view. Yeah, look at our real view. That's that tree. Oh, there's something right there coming out. So right now this is M75 we're trying for. A hazy spot or fuzzball. Will be quite low on the horizon. Yeah. It's difficult because it's so far away from any easily identifiable stars. We've got one star there. That's really gives me hope. Well, guys, 10 minutes from, oh, actually the sunrise is at 6:23. So we're at 18 minutes till sunrise. Man. Rats. This is partly due to, on our site, the fact that we've got this tree. Does DP, maybe you're going to ask about Deep Sky Planner. You're asking, does it allow you to, I bet you're going to ask, Marco, if Deep Sky Planner allows you to a custom horizon line, and it does, and I have that. But at Messier Marathon, I basically don't use it because those custom horizon lines are always an approximation. And look, the fact that we can see that star is probably this star here. It's a who knows which star it is. Look at that little satellite creeping across there. I mean, maybe we're seeing through the tree. We might be seeing, oh, look, 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 look. Woohoo! We're seeing through the tree branches, I think. You know what? That very well could be it. Then again, maybe not. But that is so close, isn't it? And it is fuzzball-like. You know what? I think that's it. I think we're gonna assume. Does DSP calculate the time of unobstructed visibility? You know, it does in a manner of speaking, because you can. There's a setting here you can say by local horizon model. You know, but like I say, we just don't use it for Messier Marathons because it isn't exact enough. I mean, literally, the tree branch could grow since the time that I shot the horizon with both the camera and also with the sort of like sextant of the telescope. Another thing that can happen is you could shoot the horizon model in winter, and then the leaves come out on the tree and ruin it. So it really is an approximation. We're seeing something here now too. M75. Let's take a look at what this should look like. It's M75. There should actually be more stars visible than what there are. None of these others are going to work either so far, I don't think. M55, excuse me, is only at 3 degrees above. We already did M15, and so far we've got a target at 3, a target at 6, and then 2 targets at 4, another target at 3, and then the one we're not going to be able to get is -10 above the horizon. Let's see. Flatwater 5, you ask, how are you holding up, Doug? No problem at all. I'm having fun. Can't hurry a good thing, Stu says. Books, you're back. You're from Australia, folks. I think Melbourne. Wow, I can't believe you're still going. Stu says, yeah, I want what he's on. Stu says, high on life. Yes. Marathons only go for about 2 hours, probably 5 if I'm running. Oh, you guys are fun. What we're doing now is we're tracking the imaginary spot that M75 would be in if we could see it behind this tree. But as you can see when we look here, it is behind that tree, and we're not going to see it till rise up. Look at this satellite. It's Cosmos SkyMed 4. You know that you're not able to catch your Messier Marathon if you're tracking satellites. Let's okay. I mean, we're getting closer. If this line, which I think it is the actual horizon, if this line is the horizon, then we've got eight degrees yet. That's just sad, isn't it? That we could have to wait until this gets to 14 before we see it. Like I say, these are showing up because they're in tree branches. We do have one up here now. And one here. Oh boy, look. We have 2 or 3 here. Let me look at the star chart that they give us to find this baby. No, it's just impossible to see what stars these are, especially because we haven't plate solved. We could go up above it and plate solve. Like, in other words, we could go up to this star, 57 Sagittarius. Let's do that. Let's go to that object. And then let's attempt to plate solve here. And that way, we'll have a reliable view of this part of the sky down to the like tenth of a degree, tenth of a minute, you know, tenth of an arc minute. Stu, I think you're right, Stu. Time to get the chainsaw out. If only the scope lifted up higher, maybe 50 foot. Okay, so we were 0.1 degree off, tenth of a degree off. And now we're plate solved here. The mount is synced. So now let's go back to M75's imaginary location. Let's run our model again. It's at 7 degrees above the horizon. So back down we go into the tree. But now we know that we're aiming reliably, and we can now use our crosshairs. So right there is where this object's going to be when it finally shows up. Isn't it too bad that it wasn't in this little crevice? Boak says it interesting that the moon is near enough to M8 and M20 that we can compare size. I never realized M8 was so big in angular size. And then Stu says we started streaming 10 hours ago. Wow. Yeah. Come on, tree, get out of our way, please. We need M55, M75, M2, M72, M73. So 5 things that we ought to have gotten if it weren't for this tree. And then M30, which I don't think we'll be able to get, just because there's a building in its way, and there's no hope with the building. 6:23 is sunrise. It's 8 minutes away. Well, we had to build the observatory in the spot that we could build it. So it's right here. And you can see it's got some trees at the north horizon. But the north horizon is not the one that's giving us trouble. It's this east. It's east-southeast. So you guys are talking about M8, claiming it as your own. I kind of think that this might be the top of the tree. Because look, these stars are starting to show up. And there's one there. That giant red X keeps getting in the way. What's the temperature? 18.9. There is something starting to look like a star here. We've definitely got a star there. We have 2 stars here, a star there, 2 here. you kind of like back off, you can sort of imagine where the branches are. These are very promising here. This is the part of the marathon that is so tense and frustrating. 2 years ago, I didn't have the observatory yet, of course, and we had gotten down to the end. I'm trying to remember. So in other words, I had polar aligned the scope out there on a tripod, and I was a little bit farther west on this road. And the group of guys with whom I was observing, again via EAA, and we were on a Zoom call, so we actually had 6 guys with scopes. We were in a similar situation. We came down to the last 10 objects. And as it turned out, I happened to be able to get all but the last, M30. And there was a tree in the way, but it wasn't this tree. It was a young tree. And I actually took a giant Celestron power pack flashlight and hung it on a branch to weigh it down so that it would bend the branch out of the way. And we got M30. That was the first year. Here we go. So let's deep sky image annotation. Right there should be M75. So it's going to appear right here as soon as it gets out of that tree. So we bent that branch down out of the way and managed to capture it. And we were able to get all 110 objects that year. But there were 6 of us observing. So we had the combined expertise of all those guys who were a lot more experienced. And we also had the combined help of all their locations. And each location had a different helpful horizon. Are you guys seeing this? Are you catching this? We're coming out from behind this tree now. This is a very good thing. Sunrise in 2 minutes. Boy. So that was 2 years ago. Then last year, we had a similar situation, and I could not get it from here, no matter what I tried. And I don't know. We didn't have the observatory done, but I had the telescope set up on the concrete pad where the observatory was going to be, and we just couldn't get M30 there. But there was a guy, he's been on the broadcast tonight, Mike Jerry. Mike observes from a desert out in California, Death Valley. And Mike was able to pull it in. You know, I think it's this. And I think our annotation is slightly off. That's it. It just looks like a fuzzball. A dim fuzzball. And let's check. It appears as a hazy spot. That's all it's going to look like, is a hazy spot. That's it. So we waited all that time for that. M75. Now let's try let's see which one's best here of the ones we need still. We still need M55. It's at 5 degrees above. So let's go to M2. It's at 6.9. and see what we get there. We could be into a building for, oh, look, there's M2. Nice. That's actually decent, isn't it? What do you got on M2, Stu? Hazy star. 50,000 light years, 150 diameter. And let's try for M72. My goodness. I guess it's that. M72, a very small globular. It may appear as a tiny comet. You got to have a 10-inch telescope or larger. 60,085. So it's that. Right there, I think. You know, we're starting to lose it in the sunrise, I think, too. Yep, that's it. Boy, that was faint. Woo! A faint splotch, we're going to call it. M2. Oh, it's one of the largest known globular clusters. How many objects have we done? Well, let's take stock here. We need M55 still. Let's see if we can get M73. It's a multi-star system, 4 stars. And there you go. See this? That's it. That's M73. Isn't that wild that he saw that as a potential comet? So now we're down to needing 55. It's at 6 degrees. That's getting better. We need 55 still. Oh my goodness, look at all of its beauty. Did you ever see a more beautiful globular cluster in all your life? M55, gorgeous. Woohoo! It's gorgeous because we need it. Okay, so there's M55. We've got 75 now. We've got 15. We've got 2. We've got 72. We've got 73. We only have one left, and it's the killer, M30. So we have 109 objects. To answer your question, folks, 109 out of the 110. But if you remember at the beginning of the whole broadcast, I asked, can we get 109 objects? Because that was the dare. I don't think there's any way we can get M30. Let's just show the chart on M30 so we get an idea of where it would be. M30 is right there right now. And the problem with M30 is, with the location of the observatory, see, this is the front wall of the observatory. The problem with M30 is, once it rises up to here and gets above this little road and this little knoll, there are trees there, and then it gets up into this awning. And once it's in that awning, you have to wait till it gets here. And by then, I mean, what time of day would that be? Let's figure it out. Let's go down here to the, let's speed up time. Oh my goodness. And it rises in that direction too. So see, we're not going to get it in between that awning. And once it hits this tree, unless by some hook or by crook there happened to be a branch out of the way, we could shoot under the awning, which I don't think we can do because the building's there. Then once it gets here, it gets into this tree, and then we're right back into the tree again. And M30 doesn't actually rise above the tree until seven. $50. Sadly. And that's M30. So I mean, maybe we could catch it down here. So that's, I mean, that's 7:56. And the sun rose at 6:23. So M30 is just going to be impossible, I think. Right now it's under that asphalt. You know, Stu, you've been here for every object. I honestly think, you're nice, Stu, to say that. I honestly think, Stu, if you wouldn't mind, you've been here for every single object. We need to turn this in together. You got to be on this. So how do I get your, I guess offline, I'll just ask you to write emeraldhillskies@gmail.com. If you could write that, Stu, just send me an email, emeraldhillskies@gmail.com or doug@emeraldhillskies.com. Either one of those work. doug@emeraldhillskies.com. And send me your email, please, and your name. And we'll turn this in because you've been here for every object. You deserve to go into this as well. M30 is the only crazy one. It's still 6 degrees below, and the sun already rose. Boy, the west is still dark. It's still really dark. I don't see how. Oh, look, I'm wrong. Darkness extends till 6:23. But the sun actually rises at 7:51. Now this makes things better. Astronomical darkness ended at 6:23, but sunrise is at 7:51. Let's go back and take another look at this. Let's speed this up again. Oh, not that fast. Sorry. Got a little carried away there. Right there. So if the picture is right, it could be 7:58. I mean, if the sun's rising over here, which is what it looks like, we might still have a crazy wild shot at this. So, I know you guys have got to, you got to go. I mean, Stu, what time is it there? It must be, is it 8:30 or 9:30? I don't know what time it is there in Tauranga, New Zealand. You got to hit the sack. But thanks for getting us through 109 objects. Laura, welcome. Good morning. Laura, we have 109 out of the 110 Messier objects. All we need is this one single globular cluster called M30. And it's currently at 6 degrees below the horizon. The sun rises at 7:51. This might still happen, guys. Stu, he's really going to do it? He's going to stay up for another hour to get the last one? He must be mad. Yeah. No, it's once a year, Messier Marathon. Laura, thanks for saying congratulations, Laura. Stu has been here for the whole time, Laura. He's hit every object with us. And Flatwater 5 picked up for the morning run and covered the last 40 objects. Flatwater 5 was here too, Laura. So those guys have been very helpful. Well, if you're going to run a marathon, you don't stop in the last 50 yards. Well, I tell you what. You gotta love it, don't you? Five degrees below the horizon. Wonder if the telescope would protest. Flatwater 5, yeah, someone's had to work all night. I am never helpful unless you're in a terrible musical references. Laura, this is really epic. You're nice to say that, Laura. Kind of play along. Well, I think we're ready for some yogurt, don't you guys think? Or maybe some applesauce or something? Let's go with applesauce and then yogurt. I will take you guys so you don't have to watch me eat, and I'll mute myself just for a second. Okay. Let's see. So we're looking at the moon here, of course, and most observers like it better when the moon is not full because, as you can see, the best observing happens along this line between light and dark. And that's because along that line, the sun is striking these features and casting longer shadows. Whereas down here, when the sun's hitting the moon square on, you just get more like, it just looks flatter, and this looks more three-dimensional here. We call this line the terminator, no relation to Arnold, but this allows us to study these craters one at a time with great detail. You can actually see the little splash of materials that sort of bounced up in the sky and then fell back down to the middle of the crater in some cases. You get these rays that emanate out where material was splashed out when the projectile hit the moon. So it really makes for a better experience when there's a partial moon and you're studying things along this terminator. So as you travel through the month, you can actually study features one at a time across each stripe of the moon and get to know each one. And some planetarium software lets you study the objects on the moon in great detail, like Stellarium is a free planetarium software, and you can actually identify the main features and then look for them on the moon. Like here's this, crater here. Here's the different mountains and the different seas. And then you can go compare those to the real thing and try to identify them. And I have just a few of the features turned on, but this is all, controllable from within Stellarium, how much detail you want. And a lot of people, of course, really love to study the moon. I've never gotten into it that much, but it is kind of fun, isn't it, to know that you can study those features one at a time. Like there's that crater that you see right here, for instance. So that's kind of fun. Okay, let's get back to business here and see how we're doing. Let's refresh. We're at 3 degrees below the horizon still for M30. So let's show that on the chart. So still viewing live through the asphalt. I was going to show one other thing that we could look at. There is a bunch of volunteers that keep track of the people who have participated in the Messier Marathon. Sorry this is so bright on your eyes. And they do it here at the site, messier.ceds.org. And they kind of chronicle it back 1 year at a time. So, you can go all the way back to the very beginning when Tom Huffelder and Tom Ryland of Pittsburgh noticed that it might be possible to observe most, if not all, of the Messier objects in one night around springtime. because there was a gap in the objects around the sunlight that time of year. That was in 1976. So they decided to try it in 77, and both of them did a marathon, though they moved. Tom Huffelder moved to Akron, and I guess Ed Flynn joined Tom Ryland. And that year, Tom Huffelder notified Walter Scott Houston, who was a editor of a column at Sky and Telescope, and he published the story in March 79. By that time, Tom had already moved to Florida. And Don Machholz saw that article. And interestingly, he had started wondering about this in late 60s. But he didn't actually try to do a Messier Marathon till 1978. And Don Machholz then went on to write this book, Observing Guide to the Messier Marathon. And so you're seeing kind of the beginning of the whole idea just in the 70s. So here you have the first marathons we know of in the 77-ish, and people logging it. Finally, you get to 1985, March 23rd, 24th, and this guy, Jerry Ratley, actually did all 110 from Dugas, Arizona. And that was in 85. Then you start seeing others, Phil Harrington, several folks kept on at it, and Phil's kind of a vocal. I think he's done, I don't know how many he's done, a dozen or more. Don Machholz has done like 16. So you can study all the way down through the history a year at a time, and then you get to 20, let's see, 21, I guess. What is this little dialog box here? It looks like SharpCap has stopped responding to keyboard and mouse. Wait and see. We're going to have to investigate that here for a minute. Let's I think it's still working, isn't it? Yeah, seems to still be working. So I don't know what that little box was all about. You get to 2020, here it is, 2021. The group that formed out of a Cloudy Nights forum, and that was Roll, Robert, Jeff, Sanjeev, Doug, Frank, Gary, Phil. And you saw Frank checked in tonight. And this was the first time that we know of that anybody on anywhere of this list had done a Messier Marathon over Zoom. And in 2021, this Zoom group that we had, it was the only group that did all 110 objects. You can see the others all missed something or other. Then in 2022, we got the group back together again. We called it the EAA Global Team, and it was formerly the Cloudy Nights EAA Team. And that year was Jonathan, Roll, Tom, Brian, Jeff. By the way, Jeff stopped earlier in the night. Mike, Jerry, he stopped earlier in the night. Doug, Brian, Michael, Marco, Frank, he was here. And Kim was here when we started. We did it at March 5th through 6th, and we only got 109. And then we did it again a month later in 2022, and this time we name all the people that took part, and this time we were able to get all 110. And this was during COVID, so It was really fun that we were able to do that over Zoom and still keep it active during COVID. And again, in 2022, that group was the only one to capture all 110. Now here's 2023, and these folks are attempting and scheduling it. They're talking about they're going to do it, but so far, nobody's actually logged any completed marathons for 2023. So that's fun. Then there's a thing called, what do they call it? Oh, it's something like, Eternal Hall of Fame. I think that's a little bit of a dramatic name. And in the Eternal Hall of Fame, you can see all the times that we know of that anybody's actually completed all 110 objects. You can see in 2020 there were none. There was none. So then in 2021, just that Cloudy Nights group did it. 2022, just that EAA global team did it. And boy, if we could just get M30, then we would be able to turn it in and presumably see this happen again. But you only get honorable mention if you get 109 objects. And these folks got honorable mention in those years. See, there's another thing. I think we ought to close SharpCap and reset that. So let's close this camera and close the program. So it's kind of fun, you know, that these volunteers have tracked it all these years. Hats off to them that they're willing to do that. Let me put this back now in something dark again because that's so bright. Let's bring this up to date now. Catching up with you guys. Different games you're talking about. So you're doing this for bragging rights. Fair enough. No, not really. But it is a small select group. You're right. More so doing it just because it practices your muscle memory. The first year I did it, it was absolute pandemonium for me. It took me, I remember it took me 2 hours to get focused the first year. It was horrible. I had just acquired the scope. I had just acquired the focusing motor. It was horrible. And I really depended almost all on the rest of the guys. The second year was better, but I still felt like I was limping, you know. And you guys be the judge. This year it's felt pretty smooth, hasn't it? I mean, you can tell we're still learning things, but it's a lot better. I think that's what the Messier Marathon does for you, is it forces you to, your muscle memory, to get better at things. So, okay, here we go. Now let's go back to our M30 and let's set this on something other than the moon. How about that? 2 degrees below the horizon now. Has something gone wrong with Stellarium? I think it has. Let's close Stellarium too. Wasn't a limp, but a sprint. You're very kind, Stu. It does feel different, doesn't it? If you go back, we've recorded these each year, and you can go back at Emerald Hill Sky's YouTube channel, and you can watch pieces. In fact, the first year we did a 30-minute summary of the whole 12-hour marathon. And you can watch that 30-minute summary. And it's a fun story to remember that. But boy, my part was just completely a loss. It was just jogging along with the team, really, more than anything else. I guess we could 2 degrees below the horizon. Let's go to something like the Elephant Trunk Nebula. Get it off of that bright moon. Laura's hearing the Jeopardy theme song. So now you can watch the scope there. You can also watch it slewing here. Takes a little bit of the Jeopardy theme song away. Boy, you can sure see the sun rising over that horizon, can't you? It's the smell of astronomical death. And we'll do a plate solve here. Stu's asking if we're going to post this 12-hour stream. The thing is, Stu, it will be posted the moment we stop the broadcast. It's already there live. So it really is cool the way YouTube enables you to stream like this. And yeah, it'll be live the moment we stop the broadcast. So this is the Elephant Trunk Nebula, or the Elephant Trunk Nebula, or IC1396. IC1396. And let's just go back to the 22nd with a gain of 100. And reset that, and reset this. Oh, sorry. Thanks, Stu. Reset this, and then reset that. This is an interesting nebula because it looks so looks so much like nothing there, doesn't it? And I love it because out of that nothingness then starts coming something eventually. It's just fascinating to me that these objects are up there and they're so faint. So you can start to see some nebulosity around those couple of stars there, but still there's really nothing here. You go back here and you zoom in and you say, wow, how can all that be here? How can all that be there? And it's because it just needs time. Layer upon layer upon layer. And you just have to let it cook, which is to me fascinating, that there is nebulosity there, but it's completely invisible. And if you look real close, here are those two central stars that are illuminating the thing. So all we can see right now are those two stars. And then little by little, the nebulosity begins coming out. Over time. Seems like it's just a fascinating concept that this stuff is kind of waiting to be discovered. So now, if you're very, very, very astute, you start looking and there are some funny black patterns. That start to kind of make their way out. And at first, the black patterns are like shadows. You're thinking, what is that? And then little by little, there's more and more nebulosity. Pretty soon, you realize this entire frame is going to be nebulosity. Elephant Trunks Nebula is a concentration of interstellar gas and dust within the much larger ionized region IC1396, located in the constellation Cepheus, about 2,400 light years away from Earth. Thank you, Stu. Of course, one of the issues that we're going to have here today is the fact that the sun is going to be rising, but see how there are these, you first look at them and you almost think, is that my imagination, or is there a black trail there? Are there shadows going on in this? You start thinking, that's like a shadow. And stuff like this, to me, is really interesting because it really does sort of grow you as an observer. You think, what? Is there really going to be something there? And it's so faint, it just has to boil out of there. Right here is the beginning of like a river of dark matter. And then when you come over here and you see these different rivers, like that river we're seeing is right here. But this nebulosity is so faint. You have to wait on it so much. There's that black canal. So some things just require this kind of patience. This would probably take us, 30 minutes. Something like that. So I'll cut to the chase here and go to I see 1396. So this is 3,000. This is 60 minutes. So here's 60 minutes of waiting. That's one view. And then here's a better view of it, perhaps. That's 60 minutes later. Just tons of faint nebulosity that little by little came onto the scene. And I think this is the part that's typically described as the elephant's trunk. And that's like the elephant head and the elephant eye. 60 minutes later. It's crazy, isn't it? So we're at 9 minutes, so we would have another 50 minutes to go. This is one of the tougher targets, I think, for obviously visual observers. There's nothing. For a visual observer, you see nothing here. It's got to be done with something like EAA or astrophotography. Let's go back and check our globular cluster here. 0.6. All right, we're gonna stop this just because I'm wondering. Let's now we're above the horizon, so we won't tear up the scope. That's the sunrise. How about that? This must be the beginning of the sunrise on the, let's see, let's make this match it. Show chart. Yeah. So this is the tree, I think, with some of the daylight starting to show through the back of the tree. But again, it's not an exact science. There's definitely some daylight peeking in here. Let's turn our gain up as high as we can get it. I think it goes up to 600. And let's bring these milliseconds down. A lot of daylight in that picture. Get the chainsaw out. Sky looks blue in the slew cam view. Oh my goodness. You're sure right. Look at the sky cam. Woo! That's horrible. You guys don't have to stick around for this if you don't want to. Let me dial down this. Let's see. How do I get back over to that? There we go. Let's dial this down. Boy, that doesn't feel like it's responding. It's crashed as well, I think. It's weird, isn't it? Too much light for it, I guess. Boy, it's just flooded with light, isn't it? Huh. So what would this be? Maybe the neighbor's some kind of light, huh? Wonder if we could still get to a star. Let's try to, let's see if we can still see this star. So bright. Thank you, folks. Flywwater 5. Hope you get some rest. Thanks so much for being with us. Yeah, even that Saturn is still below the horizon here. So that makes you think that this line is accurate. Let's find another. Here's Altair. This should give us a read on a pretty bright star and see if we're able to pick it out. Flywwater 5, thanks for your help, man. Thanks for teaming up with us. Well, there's Altair, so it's still showing up. That's 100 milliseconds. Let's see if that will plate solve. See if there are enough stars there. I don't know if there are or not. Again, just try to get our bearings so we have an accurate read on the sky. If it'll let us plate solve with those stars. Only 15 stars there. We'll see if that's enough. Oh, it did. And it was off by a degree, so I'm glad we did. So that's Altair. Now, armed with that information, now let's go back down to M30 again. And we also now have a better reading on the part of the sky where Altair was. There you see we went below the tree. But now we know we're at least lined up with M30. And that's where it thinks we are, so not extremely encouraging. So that's the tree. It really is bright, you're right. Crazy, huh? Of course, we have that camera set on night vision. Let's go to that camera. Let's see. Let's take it off of low light compensation. So really it's something like that. But you're right, it's still bright. Man. At least we know now that we're synced with it. Stu, what time is it there? Is it 9:30 in Twaranga? 9:30 p.m.? You were asking if we could see it first thing at night. No, unfortunately. The sun is still out when the sun doesn't set in a way that lets you catch it. In other words, you can't get it on that end of the sky, unfortunately. This is the only time you can get close to it. 12:30 a.m., Stu, you should go to sleep. On Thursday. It's a crazy time zone world we live in, isn't it? Crazy time zone world. Now we're seeing some trees, you know, some tree limbs, aren't we? This is that sort of mottled look that we had a while ago when we started seeing a star now and then. Yeah, I don't know if you can see that, but you can definitely now begin to make out the shadows of the tree limbs. I'm good till 2 or 3 a.m. We really don't need to have much of a view of it. There's not a lot to see of M30. It's going to look like one of those fuzzy balls. It's going to be, oh! Sometimes you kind of have to use your imagination. Again, it's going to be right there. We're just at 100 milliseconds. I wonder if we should go, let's go to 150 milliseconds and see what happens. I kind of like that. A little bit more light. Let's go to 200 milliseconds. Right here. There's a patch of sky right there. Just to try it, let's go to 250 milliseconds. Boy, it's getting close, isn't it? Man, can you imagine we're going to be able to see a globular cluster there? Kind of just look like one of those fuzzy balls. Not that big. Look, here's blue sky here. We're getting close to the top of the tree now. When it's 6 a.m. in dawn in Shanghai, it's 6 a.m. in the middle of the night in Xinjiang. Just do not have a good M30 horizon. It's 3 degrees above the horizon now. And if our eastern horizon didn't have that tree and that building, but I knew when we put the observatory there, this would be trouble for M30. But it was really the best location for the observatory, unfortunately. Excuse me. I've thought about getting a separate scope altogether and call it the M30 scope and set it up at a location where we could see low on that horizon. Maybe put the scope up on top of the building. I know, Stu, the tree does look like it's high on the horizon, but maybe it's because the observatory is up on the high part of the property and the telescope is up about 12 feet. I'm afraid that tree is in the wrong place. You guys really have the answer when you say bring out the chainsaw. Boy, I wish it would just peek through, don't you? I wish it would just peek through one of these little open patches. Man. What if this is no, it looks like it just looks like patches of daylight through that tree, backlit daylight. Stu, I'm hoping for the best, but expecting the worst. Well, the worst is we get honorable mentions, Stu. I mean, we've already got the worst. We get honorable mention in the Eternal Hall of Fame. Imagine. Oh, boy. with it. In other words, is M30 bright enough so that it will still show up even after it gets above the tree? Man, we're going to have to go down to 100 milliseconds now. Boke says, I love your positivity, Doug. It's infectious. And Laura says, 24/7. You guys are encouragers. The worst of the best. I can live with that. A treehouse observatory. I love it. Up the tree. You know, I mean, just any kind of long lens that could mount up high and see the zero mark of the horizon in the M30 direction. That's what we need. But on the other hand, think of it this way. This Saturday, it was going to be cloudy, and we wouldn't have gotten to do any of this. So we just had to kind of adapt and go with Tuesday night, and that let us get 109 of these objects. Stu, it's getting cheaper and cheaper to launch a telescope into space. For a measly $3 million, we could have This is a good sign. Look up here. That could be the top of the tree. Now, let's figure out our strategy. If we do get to the top of the tree, what if we went with something like 30 milliseconds and 400 gain and then live stacked? I bet that's the top of the tree coming up. Stu says, we can always try again next week. Pray for fine weather. Cross fingers and do a dance. I don't know whether I'm up to doing another marathon in a week or not, Stu. And some pruning. Now you're talking, folks. 2 marathons in a week. Yeah, measly 3 million. We are getting to the top of the tree, folks. What's that old Elvis Presley song? Was that Elvis? It's now or never. I forget who that was. Put the space scope at Lagrange 3. Lagrange 3 and extend your viewing time. That's good. 5 degrees. M30's at 5 degrees. A great video on YouTube. Search for all SpaceX launches short. All right. We'll have to do that, Stu. Thanks. Well, this is it, gang. In just a few minutes, we're going to know if there's any possible way to pull this out. I think what we're going to have to do is plan on some short amount of time with whatever gain we can manage, and then live stack that and hope to pull it out of the morning. But boy, now I'm looking out even in the west, and the whole sky is lit up like dusk now. So I'm kind of like used to, you expect, what was your famous phrase? You're hoping for the best but expecting the worst. Laura, thanks for checking this out. Here we go. 11 hours and 41 minutes. You know, I think YouTube stops a live stream after 12 hours. So no matter what happens, 18 minutes from now, this will be over. YouTube will for sure see to that. Gonna have to turn the sun off for a short period. Okay, so right here is what we're waiting for, and we want to start experimenting now with that. Daylight out there. It's too bright. It's just too bright. Stu is reminding people to click like and subscribe if you like. For some reason, the comment won't show. Our exposure is 7 milliseconds with a gain of 400. And I think we're going to have to go down to 5 milliseconds. I wonder if that's the corner of the building. It's just too perfect of a line, isn't it? Look at that. It's a perfect 45-degree angle line. It means a lot, you guys that have stuck around with us. We have 11 on the stream now. Feel free, you guys, if you want, if you could, you're welcome to remind us where you're logged on from, especially if you haven't spoken up. We've got Boaks and Laura and Stu that have spoken up, but it's been a while since others did. If you're watching live, and if you're watching recording, thanks so much for taking part in this. It's been a fun adventure, and 109 objects is not a terrible outing, so thanks for being a part of doing this with us. Okay, so right here is where we're watching. That's where M30 exists, if we could just pull it out of this morning light. What we've got is the side of the building, and then the tree limbs that are alongside, apparently. I don't understand how that works, but one of these edges, apparently, of the building must be projected there. So right there in the middle is where we're working. We're going to take this reticle off. We're going to watch right there. We're going to start live stacking. As soon as that tree is out of the way, let's drop to 2 milliseconds. M30 is not this bright. One of my coworkers, mid-staff, he's here in the office. Do you need coffee? It does seem very straight, a perfect 45 degrees. So I think the picture is not exactly aligned, you know, exactly perfectly. No, Tim, thanks for offering. I think I'm okay as far as being awake. It's just, Tim, we've got 109 out of 110 objects, and it's just honorable mention on the Eternal Hall of Fame. But if you go back and look at the video, remember the subtitle, Can We Get 109? That was the subtitle, because I knew this one would be impossible. It would be impossible with the time that it was rising. Okay, so let's go to 1 millisecond and then stack. But see, I think if we live stack and all that stuff's gliding across, it's going to be ugly. We need to wait till we have a clear shot. This would have been next to impossible just a few years ago. I feel it's a privilege to be here. Thanks so much for making this possible for all of us. Stu, you're so nice to say that. Yeah, you're right. I don't think very many people had their telescopes set up on an amateur level anyway to do a live stream through the telescope even, I don't know, 4 years ago, literally. I think this all burst on the scene around 2018-ish, so 5 years ago is when this first became a possibility with these CMOS astrocams, and with the onset of quality live streaming and video conferencing apps. Also, that's a big part of it. Stu's taking you up on the coffee, Tim. Trouble is, he's in Tauranga, New Zealand. Tim, you were just down there 2 weeks ago, I think, or 3. Okay, here we go. We're going to be in solid daylight here. 0.7 milliseconds. We have 9 minutes left on the live stream from YouTube's point of view. Okay. Daylight, finally, at 7:50. Jaffo, good to have you here from Dayton. Yeah, Laura, you're right. That coffee will be cold. It does give you a sense of how quickly objects rise in relation to things that are close here on Earth, doesn't it? We don't normally see we can't normally get a sense of how the sky is progressing across our point of field of view because it's so far away, we lose sense of perspective on it. If Stu is in Twaranga, that's exactly where I was. How about that, Stu? Tim was in Twaranga. Oh my goodness. Where are all these limbs coming from? Once again, I think we should thank everybody who logged on throughout the night and cheered on the effort here. Thanks especially to Stu. You've been indefatigable, and it's 2 a.m. or whatever where you are. Pretty amazing. And if you're watching this as a live stream, as a recording, thanks for logging on and watching the recording too. We ought to thank God for making all these cool objects and making it possible for us to be able to observe them. Boy, I wish we could see through those little patches. We've just followed it up this entire tree, haven't we? Look at that. So the picture is more right than we thought. I guess it's possible that that 45-degree angle could have been something down here. Five minutes left on the 12-hour YouTube broadcast. Stu says, longest live stream I've ever been a part of. Jaffa, light pollution so bad here, it's hard to count more than a dozen stars. Growing up in eastern Kentucky, I really miss the night skies. Well, you're right. We should campaign against light pollution. Boy, are we seeing it behind there? You guys would say I'm dreaming, huh? If I keep rubbing my mouse around in a circle long enough, will it